Start. Yeah. Okay, sure.
Hello everyone, welcome to RISC 2025 at CSE IIT Bombay. We have a wonderful set of presentations, panel and posters lined up this weekend. We hope that you have a lot of fun and also take away some valuable insights from the program. Without further ado, this is Professor Varsha Apte, Head of Department Computer Science. I invite her to give the inaugural address.
Thank you. So welcome everyone. Good morning. Good. At the very first try. Thank you. Welcome to the Research and Innovation Symposium in Computing. In my time remaining, I'm going to try to do just two things. Quickly give you an overview of the department. It's just something that since I have, have you here, is good for you to know some numbers and some things that we have done recently. I just want to tell everybody that this is near the entire gamut of sort of achievements or other sort of things that we have done in the last few years. But I'll just go over it, and then last couple of minutes I will try to tell you what our intent is in asking you to come here and sort of listen to us. So this is just, CSE department, 48 faculty members, more than 1100 students of all kinds, UG, PG, PhD, and we are spread across 2 buildings. Our program is very packed, but if you want get some time, you can ask some volunteers, they can take you around a little bit if there is some break sometime. So what do we do here? What do all of these people do here? Either they do or they support, not only what they support research and teaching here. Today, this program is about research, so I have mainly talked about research. So there are roughly 3 streams that we divide ourselves in. The computing systems, which is sort of the infrastructure, the hardware and the software that underlies everything that runs on it. So we ask and answer questions related to this infrastructure, or we run sort of systems-heavy applications, that also goes there. Then we have a stream called intelligent systems, otherwise known as AI and ML. And then theory, just to rhyme with everything else, we are calling it theoretical systems. But it is a big ellipse there, it encompasses everything. It asks questions about everything. It's not a really thing by itself. It is fundamental to everything else. And then these are sort of the sub areas in each of these streams. In AI, we have vision, we have text, we have audio, of course, speech, representation. In computing systems, there is at UG level equivalent things to networks, operating systems, compilers. In theory, of course, algorithms, complexity, formal methods. I hope that you'll hear about this field. It's not a field that a lot of universities students are exposed to. I think we have a couple of talks in this today and tomorrow. Then we also have a few faculty members focused on asking questions which are directly sourced from the issues on the ground, and then the trust lab. Roughly equally divided in terms of faculty members, in terms of who works on this. Yeah, this is something I just do want to say everybody knows. We have a very competitive program. Just means the only reason I put it here is mainly I'm proud of this, okay, because this is an output actually, not the input. We have papers that our faculty member write, they are written with students. Okay, without students, it's difficult to write papers. If you come here, you will be, next year's or year after next people who write papers with us. But it is not easy to get into our PhD programs and stuff like that. I hope you get inspired today and start studying for the entrance exams, for the admission exams, and so on. Okay. Yes, all of this work leads to a lot of awards. It's something I'm going to not emphasize a whole lot on, but I wanted to show the updated achievements of our faculty members. And those are the people, this is the work. lot of best paper awards, lot of special mentions, test of time. There is long-term impact, not only something very small term. This is also impactful R&D work, things that, again, problems that are sourced and inspired by issues happening around us rather than starting from something in your mind. Again, I'll skip over this. Students, again, we are proud of them. A lot of, they go out and then come back and win alumnus awards. We have a very good representation. CSE department wins a lot of alumnus awards. We have many PGM winners here, which means they are the top student of the institute. Again, this is about the research work. People publish, get noticed, go on to get awards. Again, it's more to inspire you all to be the next person on this screen here. I think one of these people were not here when the first RISC was done. So now she's here. So hopefully, recognition can also inspire you, although the work itself should be inspiring, but it does lead to recognition also. Again, whole bunch of just some snapshots from our social media posts. Nowadays, we want the world to know what our PhD students, especially master's students, BTech, everything, and our faculty are doing in terms of publications. So we actually have a series where we tell on our social media as to what we have done. We have a lot of translational research going on. The papers, some of them are fundamental and they stand, sort of by themselves, but many of our faculty members like to see their ideas deployed in products, like to see those products being then, taken over by maybe some companies and so on. So that is what is called as translational. And I would encourage you to, again, follow us on our website or social media and see what we are doing, which is contributing to either day-to-day improvement of life or nation building, nation infrastructure building. These are the examples of that kind of work. We have, all of this work has to happen in some environment, some conducive environment, some ecosystem, and within the department we have research labs. We have, currently these are our three big research labs. One is Trust Lab, eYantra, GISE. I think you will hear from Trust Lab and GISE representatives separately tomorrow. eYantra, I think, is very well known, I'm assuming, among the audience here. But these are not the only, I just put them separately out because they are very large initiatives in the department. But basically all of those streams and areas that you saw earlier, they have corresponding research labs. Again, this is to say that we have very good facilities here. If it's your dream to come and do some research work, development work, translational work, whatever it is, we have the facilities to support you in that. So every student gets, every thesis student, research student gets a desk and a computer. They have like an office that they can every day wake up in the morning, just come there, hang around there, have a real sort of lab-oriented research life. Okay. Yeah, again, more about facilities for students. If you hang around in the lab, it can be a very nice camaraderie where you are learning from each other. Any problem happens, you just turn your seat around and ask a question, or walk a few feet and ask a question. It's very, we don't expect that you're just going to work on your own in your hostels or something. We have facilities for you. Yeah, again, more, we have a nice, I don't know whether, okay, that's the picture here. We have a nice lounge. Now we have a separate lounge for research scholars. We have, of course, a library, and it's more of a bring your own laptop, plug it in and sit on the Wi-Fi kind of library, which is what modern libraries are. What this department is about, what are the facilities. We can talk about more of the, offline in lunch and so on, about any other questions of curiosity you might have about the department. Also, please follow us. I hope these QR codes are the correct ones, and they are all over, so that you can follow us. Admissions, advertisements, and things like that. Everything gets posted not only on the formal places but also on social media. So please follow us there. Now a few minutes about why RISC. Why did we start doing these? We have been doing them on and off since almost 15 years maybe, but last 3 years we have done them very regularly and at a larger scale. So yeah, we want to introduce you to the R&D. And why? Because we would like you to come and do it here. Less sort of selfishly, we are okay if you do research and development anywhere. Research and development needs to get done by people in the country. So it doesn't really matter where you do it. We'll be very happy. Uh, and why R&D? Why research and development? Finish your BE, join a job, just do what you. I mean, here we have a very biased opinion. I have a very biased opinion. Want to do is something fun. It gives you a sense of ownership. It's challenging. If you think that a day-to-day sort of routine is challenging enough for you, it's challenging. It gives you a great sense of pride when you succeed. And it's what the society needs. We have myriad problems around us. We can't be the ones who say, why isn't this getting solved? We have all the means and agency and skills. If somebody is not literate, not skilled, not educated, they can say, so why aren't others solving this problem? There are potholes in the road, there is climate issues, whatever it is, somebody needs to solve this for me. But we can't be the ones saying that. We have to solve it ourselves. So solve it, and the sense of accomplishment and service to the society, nation, planet is immense. Of course, we are also very proud of fundamental questions being answered. That's a basic human endeavor. Everything need not be inspired by problems around you. There are people who think, who can just think of very essential questions of what can be solved, what cannot be solved, what can be solved in a certain amount of time, and so on. So that is also deeply appreciated. That also you can do. That is also very much fun. So the means by which you can do it here in the department, we have 3 postgraduate programs. The MTech, which is very well known, everybody knows about our MTech, where you have 1 year almost of R&D work. It's an intensely research and development oriented master's program, probably the world's most intense one in my opinion. But we still came up with another master's program, which we put the name research in the title itself, MS by Research, where it is a little more flexible here because it's a fixed year program. There is a little limit on how much hard research problem you can take for tackling. There is a little more flexibility in when you can leave in this program, so we came up with that program. Fewer courses, more research. PhD, of course, is our flagship research program. Typically, it takes about 5 or more years to do it. Each one has its own fantastic career opportunities. Also, if you're already past these stages, or you are already decided to go somewhere else for doing masters or PhD or something, then please, if you're only BA, BTech, then you can consider us for project staff. Even masters, of course, some senior technical staff, they are they are the ones who do a lot of work. Postdoc, of course, the dream is to see some of you come back here as faculty members and teach here, right? So today's showcase, it's about our current students, our faculty. Also, it's nice to see that 2 out of our 3 external speakers are our alumni. And of course, we have some, we don't want to be very inward looking. So we have some other invited speakers and panelists. So you are going to hear from them. You're going to hopefully converse with them, not only in the panel, but lunches and so on. And that's it. So thank you for coming. Enjoy the event. And now on to the main program. Thank you.
All right. So thank you, Varsha ma'am, for setting the stage for this event and such a lovely introduction to our programs. Our next speaker is Prof. Milind Sohoni. He is a very senior faculty member of our department. His research interests range from the P versus NP problem, geometric group theory, all the way to modern problems such as facilitating land records and water management issues. Today he is going to talk about digitizing land records, which is a very essential problem for Indian farmers. So without further ado, let's welcome Prof. Milind Sohoni.
Yeah, yeah. Yeah, so I thank RIS RISC for giving me this platform to talk about some of my research. What happened? Yeah. So this is about the use of GIS. You may have seen about the GISE lab. So this is some of the work which came out of that. So first of all, it is done by a lot of students and project staff. So Asim is a Bharat and I are faculty members. Asim is an undergrad student. There's a big team of undergrad students as well, and project engineers like Asim. So I'm going to talk about the problem. What is the basic problem, and why we need an IT stack for it. And then I'm going to talk about a collaboration between us and Google Research, and how we collaborated on improving some basic segmentation algorithm, and then how we decide to use it for land records. Then the actual interaction with the Department of Land Records of Government of Maharashtra. What happened in that, and where are we? And then finally we will end with sort of what is the message. So first of all, if you see the headlines, you'll see that Indian courts about 10%, or depending on the statistics, about 10 to 30% of the court cases are about land, and they are about land records. And the main reason is that the record may say that these are sort of this is land, but if you put it on the ground, then you see that there's a lot of mismatch between the actual record and where your piece of land is. So obviously, if there's a discrepancy between where you are farming and what the record says, then if you want to build a house over in this corner, right, then you are going to be in a problem, right? So essentially, the mismatch between actual physical land and the records creates a lot of friction in the economy. If you want to change land use, if you want to grow some new crop, if you want to take a loan, and so on. Right? So about 50% of Maharashtra's land have a discrepancy of about 20%. So it's a huge problem, right? So we really need to work on this problem. So the question, of course, is that how are these land records to be fixed? So first of all, we've seen, so what the proposal is to build an IT stack just for land records. So have we seen IT stacks before? Yes. The first IT stack is the transportation IT stack. We've seen Google has created, since 2000, we have this, Google Maps, and basically there is a transformation, or there's a translation of reality into some data structure, right? So you have roads, you have places, you also have polygons, and so on. And based on that, a lot of infrastructure is actually working on that. So for example, cabs, public transport, and in fact, a lot of other things, finding routes and so on, is actually working on that, infrastructure. So there is a layer, there's a ground, just as in computer systems, there is a base layer, then an intermediate layer, then an application layer, and all of these I have combined to give you actually useful services. So this is the one app, one IT stack. Then there is also an agriculture IT stack, which of course what I'm going to do is part of that. And agriculture also needs a lot of inputs from various parts. And the basic unit, the basic ground reality are farm plots, right? And on that there will be irrigation infrastructure. On that there will be energy infrastructure. Then some commercial. Where are the APMC markets? What are the roads? If I grow papayas, can my truck go into the farm and fetch the papayas and take it out of the farm, and so on? So there are many questions which the agriculture sector also needs, and one of them is basic issue of land records. So the IT stack for any sector is actually built on the basic reality, then some application, then some intermediate layer, analysis layers, and then finally the application layer. So here is where we started. So we wanted AgriStack was an initiative started by Government of India, I think about 4 or 5 years ago, but we started work on this, slightly earlier. So here is, so Anthrokrishi was a project. I think it has ended now. It has now been it has been morphed or renamed as ALU, Agriculture Land Unit Project. So what it was is that can we, given this image, which is of course several hundred megabytes, can we reduce the, can we cull out the important information so as to reduce the memory requirement, and also introduce a new conceptual layer. Yeah, what's happening? I should, yeah. Right, so can we introduce, I want to know whether this farm plot is accurate, what crop was grown, how much was the cropping intensity, does it need land, how much do you think was the yield, and so on. So we would like to build a conceptual layer above this, above the image layer, so that we can, start working, so use it for operations. So the first thing is segmentation, right? So if you look at this plot and then, somehow you sort of segment it, and this representation is a vector representation of the same image, right? And it's substantially, about 100 times smaller in size, correct? So this segmentation, then once you do that, it allows you many other things, right? So for example, you can look at those segments, look at those polygons, and curl the satellite image, right? And average out what is the green part, what is the average color of that particular plot. So here in this case, what I have done here is taken that plot and sort of smoothened out the image on that plot. So now I have an average, the average greenness of that plot, correct? And the next thing would be, how would you, if you have this average color, what would you do? Do some K clustering, correct? So if you do some K clustering, then you would get there are some 2 or 3 major clusters, and then by that you can actually say that, for example, that this was taken in December or November. So there are 2 crops. There is a kharif, which is soybean, and a long kharif, which is cotton or tur. Correct? So by this, simply by segmentation, and knowing what the village and what are the major crops, you sort of have an understanding of what is the cropping pattern of that village. That so much of tur or soy cotton was there, and so much of soybean or or moong or any other short kharif crop. So by the way, what is the kharif season? It is the monsoon season. What is the long kharif season? It extends, it extends beyond the monsoon. So it may typically be, harvested in December or beyond. So by this simple trick, we can sort of estimate what is the cropping intensity, or how was kharif for that particular village. So now, the first picture, so the first question is how accurate our polygons, right? So if you see here, this is the first segmentation. So you'll see there's a tree here, there's a well over here, and then there are, so there is the problem of segmentation, and different farms, different cropping seasons, then there may be orchards, right? You can see here that these are, and different ways of furrowing. For example, haldi, the furrow size is much larger. If you have soybean, there is no furrowing, right? And there may be orchard like limbu, Mosambi or limbu, where there are actually individual trees which are planted in a lattice, correct? So the image, just the recognition of the image and its classification over all seasons is a fairly hard AI/ML problem, and that was what Google research was doing. Our part was to give them the ideas or various metrics of how do you judge whether a plot is good or not. So there were many metrics for the plots, how good is the plot, and one of them was variation metrics. So it is, given a plot, we sort of measure how much is the angle deviation, total angle deviation in the plot. So for example, if you look at the earlier picture, right? So if you look here, yeah. If you look at this plot, this is a much better plot than, say, this, right? So if you just count the total absolute value of the angles, right, and sum it all up, you will get one metric of how much is the variation in it, right? Similarly, there would be we had some other metrics of geometric, average geometric shape, and so on. So based on these metrics, the plots were improved, right? And now I think, if you take these plots to the government, they're going to say, this is not how my farms are, right? Yeah. If there's a polygon, so it's basically how much steering are you doing? That's it. If you're driving a car along that boundary, how much is the angle steering that you need to do. Right? If it's a square, you just need to do 360. But if it's an L, then you need to do this, then you need to do, I mean, it'll be about, I think, 360 plus 180, 540. Fine? So that, that metric tells you how much is the variation. So there are many other geometric metrics also which tell you what is the quality of the plot. So this is, yes, yes, yes. But of course it should match the reality. Right? So there may be, so it depends on how many are actually L-shaped plots and how many are, you know, normal rectangles. Right? So that was one. Right, so then, by then what we did was to color these plots by their variation so that, you know, bad plots could be quickly identified and then it could be checked whether there's actually a recognition problem or the land actually is quite complicated. You know, for example, you know, a farmer may, you know, divide his piece into 2 or 3 L-shaped regions, you know, which are interleaving, you know, so they do multi-cropping, so maybe it is that. So this sort of analysis helped the algorithms sort of focus and find, you know, or fine tune their recognition process so that it could improve. So, so the other thing that has to be managed is temporality. Now, for example, Rabbi, you may, for Kharif, you may sow something, Rabbi, you may keep something fallow, right? Repartition your land. So next year, Haldi ka bhav was very good. So you devote a much bigger plot to Haldi, right? But it's the same piece of land, fine. So you really need to. It's like having temporal snapshots and trying to interleave, you know, trying to build an, you know, sort of build sort of a tree, right? Where you have not really a tree, where you are allowed to merge plots, subdivide it, but yet maintain the same geometric structure, right? So this is really important for the agri stack, where we need to track what is the farmer doing? You know, what has he or she sown? How much sort of water did she need or energy she wanted? So that again, you know, forces, yeah.
Sorry, actually in the previous segment, so when you are doing clustering, so how do you determine this value of K? Because this is correlated, right? That,
correct. So actually they are the, you know, we are providing the geometry. So they are using, you know, various other, I mean, I just showed a simple K cluster.
Right.
They will, you know, do a far more, you know, I mean, I think there's some supervised learning, unsupervised various models and so on. So I don't get into it. Sure. But I just give the basic ideas that, you know, given a plot, given an image and a plot, that plot has a certain internal correlations.
Right.
Right. So we need to exploit them.
Right. I mean, because I was just wondering that, like, determining that how many clusters is related to that what happens
exactly.
in the
that
next
needs
year.
field experience. That's why we are here.
Yeah.
So in, for example, in a village, 2 or 3 are the, if there are 3 or 4 major crops, we should expect 3 or 4 major clusters. Okay, so here you will see that 20 minutes. Okay. So here you will see that actually, you know, how the temporality, for example, over here, right? This temporality has actually, you know, that this was one plot and it, you know, it got bifurcated in the next season. So this also, you know, and of course here are some examples and some bad, you know, recropping and so on. And then we came up with a theory of something called super polygons. So it's like an equivalence relation on polygons, right, which we sort of use it to integrate. So it's in a way the coarsest possible division of the land and the finest possible division of the land, which will explain all the seasons, right? And that coarsest and the finest will tell us what is actually, you know, land control. You know, what land is owned by the farmer, right? So here, for example, if I see this, you know, that if I see this, then P1 and Q1 probably belongs to the same farmer, right? But if you see P2, Q2 and P3, this whole, this whole blob actually quite likely belongs to a single farmer, right? Because you see that the decisions are actually overlapping, right? So this helps us, so these sort of equivalence relations and metrics help us understand how land use, you know, how those land records are being. So with that we went to land records. So you know the basic problem. So let me tell you the history. So history, of course, the real serious land records started with Mughal era, and they were called Zamabandi. So in a village, you know, Zamabandi is the summation, total area, what is its crop, and how much could be the taxation, right? So it was for taxation purpose, where it was called Zamabandi. Then after that, the Britishers came and they brought Akar Bandi. So what is the difference between Jama and Akar? Shape, obviously. So they started giving shape to those plots. Right? So they started being drawing. But those were, so there was a village map and there were individual pieces of the jigsaw. Here's your land, here's that land. A's land, B's land, C's land. Did it piece together? Well, if it were made from a common map, perhaps. But that, the creation of individual plots and the village map, were actually parallel activities, right? And in olden days, this was this Moses Savangi, right? So this was a village map, and then what the government did was to scan this and produce something like this, right? So this is just a segmentation of that picture, right? It has no georeferencing, it has no latitude, longitude, no area, no scale, right? So the first job was to actually scale it, right? I know this is Savangi, so I have all those farm plots, so I put it over there, and then I scale it, rotate it, and so on, and try and get it. Correct? So then once you sort of georeference that plot, then for example, even this plot was produced by our georeferencing, right? So we tried the best possible georeferencing and then superposition, and then we understand that this is the discrepancy, right? By the way, in their digitalization processes, they use scanners, and accidentally we discovered that the horizontal and the vertical amplifications are 3 or 4% off, right? That came, so we had to actually enlarge the, the family or the, group of transformations and allow to do the georeferencing. We had to allow not only rotation translation, but also differential scaling, right? So that we could get the match. So after this, right? So what do we have? So we have this, so if you look at this problem, right, there are these, there is this land record, and there is that image. So how does the Google ALU or the Anthropocracy come? It provides us polygons for the piece of land. Correct? So now we have one polygon and we have another polygon. So we can compare the two, right? And here is the comparison. So you see now that the segmentation and the land records together give us a very good picture about the mismatch. So this sort of, so if you look at this is a mismatch, right? So this should either, we need, so basically the two polygon matching becomes an optimization problem. Is that clear? So from the image processing, which is really huge, which does not allow us to, formulate optimization problem, we have now come to an actual optimization problem. And what is that problem? Yeah. So by the way, our actual land records are a complete mess. So if you look at this is I think this is Gadinglas, which is South Maharashtra, so south of Kolhapur. So this is the mess that this is the best possible fit. You see, but that for example, so you'll see, for example, you say, why don't you shift this down? But if I shift this down, this also shifts down. Correct? And if I shift this left, right, you get the problem. So it's a global, yeah. Are the boundaries, are the plot boundaries, the land records.
The lines are the land records.
The lines
and
are the land
colored
records.
Part is
and
your,
yeah, and the smaller polygons are the farms. What do you say?
So those orange polygons are
So
produced by
orange
the segmentation algorithm.
No, orange is produced by Google, to which we contributed. Now, if you see these farm plots are much better. Their Varpi is smaller, the jiggy-jaggy, daggers, and stabs, all of them are gone. Okay, so it took us 1.5 years to get to this quality of farm plots. And then we sort of now started the matching. Okay, so the first thing when you have an optimization problem is to define the metric. What should be the metric? So we first said that the excess area should be the metric. So, if you have this, if this is your farm plot, this is your boundary, the black, and these are the farm plots, then what is the excess area? This part which is outside is excess, this part which is inside is excess, right? So the smaller, I think I need to, yeah. correct? Now that I have an excess area, right, what do? I start, now I start with the cadastral or the survey record, and I start running something like a BFS. So I take a plot, I sort of shift it, match it, minimize the excess area, then take the next plot. So basically from a planar graph, which is the survey plot graph, I have an adjacency list and I start matching them, right? I start exploring the cadastral and trying to fit it, right? So, but before we do that, you see these polygons, after all, the survey plot is a area partition. You got the survey graph is a partition of the village area into, various plots. So they piece together as a jigsaw. But while our farm plots are not like that, right? So we need to, create a planar graph from the farm plots. And that is being done through this process of Voronoi diagram. So you use the Voronoi to create, from these plots, you create a planar graph. So now there are two planar graphs, right? And you are trying to impose one planar graph as a subgraph of the other, namely the, the survey graph, that's the official record graph, onto the actual farming graph, right? And using a geometric BFS to do it, right? So that was our strategy, right? So yeah.
Well, so what is the metric for such Voronoi partition? I mean, this is not like what is the norm? I mean,
no, actually there are many variations which we had to do.
Right.
You see, for example,
Because
the two farms may start diverging.
Right.
And there's a road which is cutting across one. So there are many, the actual problem is trickier, but this is just the basic maths. Okay. Right, so now what do we have? So we have one planar graph and we have the other planar graph. So this planar graph is coming from the ground reality, the farms. And the other planar graph is coming from the survey record. Correct? So one jigsaw and another jigsaw, and we are trying to match the two jigsaws, except that one is finer than the other. Right? And now the records, which are 100 years old, a new road may have been created, the stream has changed, then the stream is actually changed by the farmer, because he or she wants the stream to behave and go, just by his boundary and so on. So there are many other issues. So anyway, this is what we call the jitter fit. So jitter fit basically is a BFS where you jitter, it tells you, basically the BFS allows you to schedule the next vertex or the next face to be matched, and then you sort of match it and then you move, right? So you jitter the next plot and the next plot and so on. So this is called the jitter fit algorithm. And then, so for example, here you see that so the red one was the initial one, and then the black is the jitter fit, okay? But of course there are some constraints. You cannot shift the plot, you cannot change the shape of the plot too much, right? You cannot make an L into an M, right? Otherwise the farmer says, this is not my plot, right? So anyway, there are some tricks. By the way, I will put up this presentation on my web page, so you can refer to it, whenever you want. So anyway, we ran all of this, produced statistics, and showed it to government of Maharashtra. Look, we can work on this problem. So they said, no, all this is fine, you are all researchers, but the real problems are quite different. So they say that in your case, when you are doing the jitter fit, the plot boundaries are matching farm boundaries. But there's a lot of encroachment. So actual farm boundaries need to move, right? And you have to respect the legal area. So for example, if there were two farmers, one was 200 meter long, one farm, another 200 by record, and this guy was staying in the district place. So this farm has grown from 200 to 210 meters, and the other guy has reduced to 190 meters, but the lengths. But the record says 200, right? So they said that farmers are very sensitive to change in formal records. So if it says 200, you have to give him 200 or her 200, right? So excess area minimizing and jitter fit has to be constrained further. You cannot really do as you want. Then also you need to identify areas where I need to do resurveying, right? So if you saw that Gardingler's map, there were zones of good, zones of bad. We need to do that, and then it does not merge with existing workflows. So anyway, they told us that there are 2 or 3 attributes which we must do. So you have just looked at possession, which is farmland boundary. There has to be legal validity, and there has to be operational feasibility. that after all our workers have to go and stand there, between two warring groups of farmers. So, you got to help us with that. So we understood their process, right? They have a long process, then we identified where all IIT can work, so actual working with an agency, understanding their SOPs, their legal frameworks and so on, and then we came to, the new design. So there were two new inputs. One was the legal land record, right? So there was a polygon, there was a shape of the polygon and some legal, how big is that land, right? And that also they needed to excavate various dusty files in various offices, take them down and then prepare it. So they did that, right? And the second thing is GCPs, ground control points. So maybe in a village, there may be about 8 or 10, pillars, right, of which the lat longs are already known. But what they didn't know was that, for example, this pillar is in the boundary of plot number 34, 35 and 36. Tri-junction pillars. What I would like is, in my BFS, so if I've done plot number 34, 35 and 36, that there is this particular pillar which is a tri-junction of these three plots and its lat long is known, so I need to, pitch it there. That is what I would have liked to do. Correct? So, but they didn't have that. They have the lat long of that pillar, but not the, the plot numbers. That is plot number 34, 35, 36. So the geometric and the combinatorial linkages were missing. So that now they are trying to do, right? So this is going to be a long process. Anyway, the other thing they said is that, these are the new metrics. So the new metrics is the GIS area and the Akarband area should match. Number two, the shape should not change, right? And number three, there is the distance to bund. So instead of excess area, they said, you should give me an indication that the farmer needs to move his bunds by 5 meters, right? So that the area between the legal area and the farm area matches. So the distance to bund was the new metric which they suggested. So just to show you an example, so here you see the distance to bund is 4.54. This is the distance to bund, this, right? And in the new fit, the distance to bund is 1.48, correct? So it was not, the objective was not to minimize the excess area, right? The objective was to keep within 3% of the legal area and minimize distance to bund. Is that clear? Right? So they said ki, this 1.48, the farmer now has to fight with the neighboring farmer and resolve. We are not going to do it. But if it's like more than 3, like 8 or 10, then we will step in and resurvey. Okay, so the work was sort of partitioned between the farmers and their neighbors and disagreement and agreement, right? And so the metric was really how much, because that is what the farmer, you have to move your bund by 2 meters. Okay, I will do it. Right, you move your bund by 10 meters and there's a well, then he or she is not going to do it, right? It needs a resurvey. So these are the change in metrics. Anyway, and the output, what they wanted was heat maps, right? So they have a survey map. They wanted how good is my survey plot, right? So in terms of, so this is the actual area, the legal area, right? How much have we allotted it in our new map, and how much was the legal area, right? And then the farm rating, how much was the DTB, distance to bund. So this was the basic, how many minutes? 5, right? 5. So this was the basic structure, and we did this. And I will not go into the details, but there's a pipeline which is now running, and we have given them that pipeline, and they are working. But they are, of course, they are not IT engineers. So they are revenue masters. They are basically, so they are not used to this way of working, setting up the cloud, then setting up some SOPs of how to do it. Even the data that we have to, provide them with data analyzers. So if they upload the data of a village, then we say, oh, this is not textual, but this is actually numeric. This is numeric. Starting from everything, you have to help them get the thing right. So we've of course told them that you should hire an IT major, and we should be the technical partners, but they should, actually take you through. But that's going to take, take maybe, I don't know how much time it will take. But anyway, so what we did was, so, overview of the problem statement and then a huge pipeline. So I think algorithms were changed, and so a new concept which they introduced was that there are some plots whose ownership has not changed that much, right? And those plots, they are the most accurate, right, in that village. So there may be about 7 or 10 plots. Can you identify those and try to build your map around them? So what we do is we actually, they are called anchor plots. So once we identify the anchor plot, the other village map is like a rubber band, piece of rubber which is sort of stretched and fit into the area. So anyway, so validation was done, and then basic, I think I've explained all the metrics. Some are really bad villages. I mean, look at this, right? Look at this. So I mean, there's no way. So they also understood that the problems are really big, and that it actually needs a new act, a new act of the government to actually resolve these problems. Anyway, so this is how how the heat maps actually change over time, or in our algorithm. So what we get and what we output, correct? So this is, and these are the so anyway, so MOU 1, so MOU 1 for finished last October. It was, I think, about MOU 2 has started. In the MOU 1 we did a pilot of about 150 maps, right? Then MOU 2 is about 6 talukas, and that's about 700 maps. And there's also, they need to match the road network, then they want to see how is the quality of GCPs and so on. So that is good, and so there's a lot more work to be done. And I think a new company was formed, an undergrad student, right? So that's Aryan. So he, by the way, a lot of the work was done by students in my data structures course, CS213 and CS213M, right? So a lot of the students are from the minor version of the data structures course. CS students, I think want to do financial, quant, or whatever. So, but the CS213M, the minor students contributed a lot to it. But this guy was a major student. Okay, he was a CS student, and they have now formed this company. And it's also doing a lot of other things. So it's called TerraStack. Where's the name? TerraStack. Right. So you can look up TerraStack, and it has now come up with a Jalgaon district, everything, right? So you can look at what all data it has to offer. So anyway, Bharat is there, Asim, Lisan. We also presented this work at the American, I think, Geographical Union conference, and it was invited to make a presentation, not just a poster. So that's good. So here's a peek into our team, right? So there's a lot of good food also, right? So a lot of fun, and looking at land records. I mean, for example, Himachal. So I'm doing another project in Himachal. The land records are called Latha, and they are on big canvas cloths. One other project which we're doing is for Lanja Taluka, which is a tehsil. We've made, we've surveyed all the roads from Wadi to school, from school to bus stop, and so on. So these are students who are surveying, right, doing field work and producing these maps, correct? And then the whole village taluka map. How good are our roads? What is the investment which is happening, correct? And put them up in the school, fine? So here is the video. Can you play the video? So let's just see, if I put up that video, right, there's a scene. Can we play? So, so there's students watching their village. Oh, this is my wadi, this is my house, here is how I walk, and so on. So this is our worker who explains the map to the school students. These are girls and boys. I mean, everyone's really curious. They've seen their own village map for the first time. They've seen India map, district map, and so on. But they've never seen a map of their own village. Okay, so let me stop here. Any questions? So any questions?
Hello.
Yeah.
Suppose the land parcel contains a hill or a depression,
Huh.
and the boundary runs through it.
Yeah. So in fact, the non-ag land, in a village, is a good indicator of how complex the land is going to be. So that is a separate, that has to be handled. So in fact, the farm boundary and so this is part of the river, road, non-agriculture land. Basically, we had to understand land use as well. So the actual now algorithm uses land use.
How about the tea bagans of like Assam and all? Because you said first you basically divided it into the crops. So there is only tea.
No, not crops, polygons. Whether it's
Yeah.
cropping land or not cropping. I
Okay.
think recognition of crop is a new product which we and Google are trying to work on called AMI. So this is ALU, just land parcels.
Okay, so basically recognizing what crop is happening is not a part of it.
No, so this is
Okay.
in the new year.
Okay. Thank you.
But you see, identifying the boundary, you see, given a image, recognizing crop for that image. But if you have a piece of land which we know is the same crop on that piece of land, the recognition problem becomes significantly easier. Because you're not the confusion. I mean, you have this particular piece which we know there is an additional information that in this part of land, the 2 points, 2 pixels are indeed, should give you the same, whichever K mean or whatever you have.
But the crop is same in like a very large area, and farmers will have smaller plots
So that they are
allotted to
identified.
them.
The subplots are being identified.
Okay.
So you saw that, no? The
subplots identified from the government records
No,
or
no,
Google
from
Maps.
the image.
Okay.
Right, from the image, if the farmer has, so, individual farm plot parcels are identified. So essentially the ALU algorithm has that, that the similarity between 2 pixels is coded into the. Yeah, so it is not based on segmentation actually. So that's the thing, that it is on a, it's like an ant which is walking across, so it has some history. So ant which is walking across the land and which is recording some attributes of that property of that which have to remain the same. So it's a more dynamic algorithm. So it's not really based on segmentation.
So what are DTB metrics?
Distance to who are you? Distance to bund.
Okay.
So distance to bund is excess area divided by active perimeter. Right, so what is the excess area? But you sort of average it out over the active perimeter. So that gives you that roughly 2 meters you have to move. Yeah, at the back somewhere.
Yeah, so what is the end goal of this? So at some point, are you going to tell?
Is that clear? So it is really that if those 2 plots are joined, then it's a very good plot. The DTB is good. So it means that there's an internal redivision which has to be done. So then they can say, oh, you two guys just sit down and now get your act together. So there are new features which we need to add.
Sir, given the unpredictability of the monsoon patterns in India,
The remote sensing data, and we have the administrative data, the remote sensing data, and we have the administrative data. So we know in this village there's a percolation tank and its capacity is so much. And in this village soybean is being grown and there's a 3-week break in the monsoon. So many cubic meters are required and so many cubic meters are there.
Any more questions? Let's thank Professor Milind for the talk. It's very nice to see people working on very important problems. So for background, Professor Milind actually did his BTech here, and his work on like P versus NP is like the leading sort of approach to this problem. But then now he's moved to solving these
harder. Thank you.
Thank you so much. We'd like Professor Varsha to just felicitate Professor.
Wanted to say, no, this is actually just our own goodies, and they are good. They are not useless. No, it'll be good. They will also get. I just wanted to add to what he said. I don't think his bio was told properly. So he's BTech Computer Science, 1987, 86. And then masters from U Chicago, University of Illinois, and then he came back here and completed his PhD here in IIT Bombay, and then has been with us. And yes, it's quite a journey from the Mulmule-Sohani geometric complexity theory, something I only know the buzzwords. From there to a lot of problem solving in water, in land, climate. He's also, what is nice, the phrase public intellectual. He's a public intellectual in the sense that he writes very frequently in very major newspapers like Indian Express. I would encourage you to follow. Just Google Milind Soni. There's a continuous list of all his articles that you will get. Very thought-provoking ideas about all the sorts of things. What should computer scientists and engineers in this nation do? He has a lot of ideas about that. So there is a lot more to Professor Sohani than we saw just in the 30-40 minutes today. So thank you, Milind. Really, really great talk. Yeah, thank you.
What we hope from RISC is, I hope that what we hope from RISC is actually achieved, and a lot more clever students start working on these really hard, intellectually hard and stimulating and still scientific problems. Thanks.
Okay.
Our next talk is also a faculty talk by Professor Sunita Saravagi, Institute Chair Professor of Computer Science at IIT Bombay. She is also the head of the Center for Machine Intelligence and Data Science, CMINDS, and was, right. She completed her PhD from UC Berkeley and BTech from IIT Kharagpur. She has also won multiple awards, including being an ACM Fellow, the Infosys Prize, and also the IIT Kharagpur Distinguished Alumnus Award. Of course, she's also had a lot of, her work has had a lot of best paper awards at top venues. Today, she's going to be talking about the limitations of in-context learning, which is very popular nowadays, for structured tasks. Okay.
Hello, good morning, everyone. So I'm going to be talking about large language models. All of us are dazzled by their capabilities. And one particularly impressive aspect of these large AI models is the ease with which they can be taught to do new tasks with just a few examples provided in the prompt. Although this capability, which is called in-context learning, is hailed as a major triumph of modern AI models, I, being an academic, will take a slightly counter perspective and try to convince to you that except for some simple scalar classification tasks or for certain kinds of Markovian language learning tasks, if you want to do any nuanced structured tasks like say sequence to sequence learning, which comes up in important applications like low resource translation or generating SQL from text, in context learning fails. And what can you do when when you encounter such failure of in context learning? So first, let us define, okay. Oh no, it's, I think this, okay, yeah. So first I want to formally define the problem. So we are talking about the model adaptation, few shot model adaptation. Let's assume that we have a trained model, let's call it m theta, which has been trained on a very large and diverse data set D. And a toy representation of a large diverse data set is in this diagram, where you have this data set D, where you can imagine that each colored ball denotes like a diverse topic or a diverse task, and you use your favorite training algorithm and you get your large model m theta, and it's large in the sense that theta, the set of parameters of the model, is very large. Now, no matter how large your model is and how diverse your training data set, you will always encounter situations, particularly when you have a large user base. For example, if 1/4 of the world is using your model, there will you will have situations where you have to learn new tasks, adapt to new tasks, and what can you do in terms of adaptation. So here we are interested in few shot adaptation, which means that a user who is interested in teaching the trained model a new task, let's denote that task as Q, will give a small number of labeled examples of input and the expected output, input, expected output, and few is the K, so K is small, and these you can think of as input-output examples which have been sampled from this distribution Q. When we want to do model adaptation, we want to find the best blend of this trained model with these few short examples T. So diagrammatically, we want to design a model adaptation method which takes the trained model and the training data set and gives us a modified model mt theta, so that now if you feed to this model a new example which has been drawn from the target task, you will get a prediction which is more accurate maybe than when you apply it on the original model. So one subtle aspect of this adaptation is that very often the model itself might have seen some subpart in its training data which is very relevant to T, but when you use standard training algorithms, then the model parameters may not clearly represent relevant tasks for what it might have already encountered in the training data. So let's go through some examples of model adaptation. So we all use LLMs for chat and conversation, but suppose if you want to customize an LLM to the style of a specific user. So this is an example of model adaptation. Maybe for that user, you see some examples of input-output response. So you want the model to take the persona of one person. Okay? Another example which is closer to the kind of problems that we are trying to solve here is say the text to SQL task, which is an example of the broader problem of text to code generation task. So you might have trained the model on the schema of a large number of databases, but of course, there are a lot of databases which are private and whose schema and workload is not available to the public LLMs, and you want to adapt to that. Even for time series forecasting, which has nothing to do with text, you have the same problem of model adaptation. So there are many challenges across this different application of model adaptation if you just think of it as a scientific problem. So one of the main challenges is that your goal is to achieve high accuracy on the target task. Now, if m theta, the trained model, was totally irrelevant to the task, then this would be an easy scientific problem. But our challenge is that the trained model is of mixed relevance to the target task. And what is of greater relevance is the samples in T, but they are very small in number. So now how do you balance this small but very relevant labeled data with this large model which is of mixed relevance? If you adapt too much, then you might overfit on a few examples. I'm assuming most of you have some background of core like starting course in ML, and therefore you understand the problem of overfitting. So you might overfit, and worse, for large language models which have the capabilities to solve many different tasks, people observe that when you just do fine tuning, then the model might forget tasks which it has already known earlier. So this is called catastrophic forgetting. So you want to, you might overfit, and also you might forget to do other tasks. And if you adapt too little, then of course you have not adapted. And the other challenge is robustness. Anytime in ML you try to do anything with a small amount of training data, you have to be very careful of the standard bias variance trade-off. You might have high variance, and therefore you have to design a model adaptation algorithm which will not look fickle to the end user. Like, at least it should be no worse than the original base model. And of course, time adaptation is another important concern. So if you, because the theta is large, you want to minimize both the time for adaptation. Ideally, you want the adaptation to be on the fly, online. Like the way to a human, if you want to teach a new task, you can teach that person incrementally, and you don't want to just provide all the examples in batch once and do offline training, okay? But on the other hand, if you do online training, then at the time of deployment, you might have to incur extra cost. So you cannot get something for nothing. Okay? Now, this model adaptation problem, it's not a new problem at all. There is an extensive body of previous work. I myself have been working on this problem for the last 20 years. You know, earlier there were models like conditional random fields where I have done work on adaptation somewhere here, okay, domain adaptation of conditional random fields. And, you know, there are, you know, some of you might recognize this as a task of transfer learning or domain adaptation. These are all different slight formulation of the model adaptation, few shot model adaptation problem that I just defined. And because of this huge literature, we cannot just ignore the prior techniques which have been proposed for model adaptation. And across the thousands of papers that have been written on this topic in the past, if I were to distill away the main methods for adaptation, I could categorize them into these 4 types. So first, the standard method is just fine-tuning and various variants of fine-tuning. Many of you might know of things like LoRa and other forms of parameter-efficient fine-tuning. These are all I'm clubbing under fine-tuning and its variants. Another method is to actually not train one homogeneous model, but to have a mixture of experts. Mixture of experts find it easy to specialize to some particular narrow task, because that expert might already have, you know, might retain the identity of the task from the training set. Another method of adaptation was with task vectors. So each task has a signature, and the giant model recognizes that signature as expressed in the task vector and knows to adapt with that signature. Like 4 or 5 years back, a very popular method for adaptation was using kernel-based methods, like where you have a matching network, like a Siamese matching network, which could reason about labels of a new test example based on labels of related examples. So in these prior methods, in all of the prior literature for model adaptation, there was explicit planning for adapting to T, either at the time of training, that you would train the model differently if you wanted to adapt. For example, in the mixture of experts, when you trained M theta, you would keep aside separate parameters for different separate domains. Or if you did standard training for the model, but at least at the time of adaptation, you would do something explicit with the T. So for example, if you look at fine tuning, okay? So when you are So when you want to fine-tune parameters for adaptation, so during training of the model M theta, you don't do anything special, you just minimize loss on the training data. But at the time of adaptation, once you see the few short examples which I'm denoting as T, you would update the parameters theta via gradient descent to minimize loss on the labeled examples. So the model adaptation procedure essentially updates the parameters so as to minimize loss on the examples on the few shot examples. And with that, you get a few shot adapted model. So this is a very efficient method. It's because you are explicitly updating the model parameters to minimize loss on the target data T. This method generally provides good accuracy on T, but it has other pitfalls. First, it is expensive. Second, when you have multi-tenancy systems, you don't even have the option of fine-tuning. So we want to look at other methods. Yes. Yes. Right, yes, yeah, yes. So, so let's look at another method from the traditional family, which was based on adaptation with matching networks, which are more on the side and which do not require you to update the main bulky model. Okay, so let's say you have this model m theta, which is usually takes the input x and predicts y, but on the side you keep around another model which can reason about when two examples, let's say if I have x and x prime, whether they are similar enough that they should be having the same label. It's like you learn a similarity function among examples. And once you have such a model and you can train this kernel method, then after that you can try to sort of train a model by taking a blend of the output from a nearest neighbor classifier with this the output that you get from the giant model. And this kind of adaptation was quite popular, and it has been applied on many different tasks. Like in 2023, like 2-3 years back, we had applied this model for adapting text to SQL generation, but I have already been shown 20 minutes, and so I'm going to skip through this old method of adaptation, which was based on kernel methods. My slides will be visible, but I want to enter into in-context learning. So with large language models, you don't need to plan for anything special during training or during inference. So when large language model came along, there was this claim made that models which have been trained with next token prediction laws to reconstruct the next token on huge natural corpus collections, they can be adapted to new tasks with just a few labeled examples provided in context. So this landmark paper from 2020 tried to make this claim that model adaptation is actually a very simple pass. It's just a forward pass over a large language model. So the few short examples that you have x1, y1 to xk, yk, you just feed them concatenated with your test example to the LLM, like you just create a larger prompt. And people observed that when you give the few short examples just in the input to the LLM, the model seems to learn from those examples in context. So the label seems to be symptomatic of a model which has been adapted on the training data. So during training here, you are not doing anything special. You are doing standard next token prediction loss. And in context learning was like an emergent pattern, an emergent behavior which you observed after this pre-training. And just after that, adaptation just is a forward pass. No gradient update, nothing special done for adaptation. So just as an example to hit how in context learning would work for new task, let's say I feed to an LLM this sequence of characters. I have not even said what is X, what is Y. I've just given this sequence of tokens. Most of you will recognize what I'm trying to get at. And I give the input to the LLM. And what would you want the LLM to output? 42. And the LLM outputs 42. And now some of you who are fans of Hitchhiker's Guide to the Galaxy might not find it surprising. Maybe it has learned that 42 is the answer for just about anything. And now you can try, though, a different example. So change this 6 bank 7 to 9 bank 7, and it gives you 63. So there is something non-trivial happening. So this behavior has puzzled researchers, also often lauded as a machine which can implement or simulate any algorithm, including the gradient descent algorithm. So when you just give these examples in context, all the self-attention kind of simulates the gradient descent algorithm. The second hypothesis was that the in-context examples essentially just helps the LLM recognize the task, because the training corpus is so elaborate that usually you cannot really surprise the LLM with providing new tasks. All that you are doing via the in-context examples is to help the LLM, zone in on something similar that it has seen in its training set. And the third hypothesis is that, that the LLM actually implements some kind of a matching, like a dictionary-based matching, and that's how it is able to do classification kind of tasks. So we will not have time to go after how these different hypotheses work, but it's actually very interesting. And if I was not panicking that I have only 15 minutes left, I would have tried to explain some of these 2-3 hypotheses. But for now, I will just skip through these parts and go to the main sort of practical sort of evaluations of how in context learning, many people, so after there have been like a pool of papers which try to explain how in context learning works. And then there have been another stream of researchers trying to evaluate in context learning on various practical tasks and comparing in context learning with fine tuning. And these are sort of across the large number of papers. These are the broad conclusions that can be made from the Markovian languages via in context learning. And the larger models show greater capability of in context learning. For example, you can get a large language model to even flip its original learning. Like you can call, night and day and vice versa, and it can be taught to call night as day. And whereas now if you have large language models with support for long context, then in fact for some tasks, accuracy, fine tuning is generally considered more accurate. In terms of robustness, when your training data is very small, fine tuning can really not be robust. And ICL also can be non-robust. Efficiency, of course, that is one of the biggest advantage of in-context learning. It's more efficient, but another big advantage of in-context learning is you are actually not forgetting old tasks. So whereas with fine-tuning, one big concern is you might be subject to catastrophic forgetting. Another advantage of in-context example is the ease of use in multi-tenancy models. So with all of these advantages, it's naturally good to try to explore, how to solve the adaptation problem for more and more tasks using in-context learning rather than invest the resources for doing fine-tuning. So I have been for a long time been interested in sequence-to-sequence tasks, but not unstructured like arbitrary text-to-text generation tasks, but structured tasks. So structured tasks are those where the probability distribution over the output given the input can actually be decomposed in terms of simpler structural units. So there are many resource poor applications that need few shot adaptation. For example, if you have designed a new custom API for your app or for some system that you are building, then you want to be able to support natural language querying over that system. You want to be able to translate to and from very rare languages which are not covered by the large language models. Text to SQL for private enterprises I already covered. So now we want to think about what in-context learning would mean when you have, yes? Those were applications where in-context learning, it makes a lot of sense. And
but can you give an example of something that can be that first definition, decomposed in terms of simpler structural? You will do it? Okay,
yes,
thank you.
I will do that, yes. So basically now let's look at what the in-context learning diagram looks like for sequence-to-sequence tasks. Now, for each input X consists of, let's say, M tokens, and you have to output N tokens after each input. So you have K such examples of one sequence to sequence, and you are given a target test sequence, and you have to predict the Y. And this output, this problem is structured in the sense that if you want to predict the true label for this test example, it can only be composed out of mixing the clues or hints which are distributed across many in-context examples. So when you want to, it has to be composed out of subparts spanning multiple in-context examples. And additionally, there is no single example which is wholly relevant to the problem, and even a single example would have irrelevant parts that might interfere. So we tried to evaluate in-context learning in a kind of a total clean room setting, because large language models have been trained on proprietary data. We don't know what tasks they have been exposed to. So in order to systematically analyze the behavior of these models for structured sequence to sequence tasks, we created a synthetic formal language pair then but this synthetic generator was inspired by classical statistical lexical translation models, for example this 1993 model. And so there the synthetic task, which will also give you an example of what I mean by structured form of the tasks. So for each task tau, we assume that we have a fixed sequence length m, and this input sequence is like a arbitrary snippet of tokens which is sampled from some probabilistic context-free grammar, let's say over some alphabets. And now let's assume that there is some implicit alignment function which says each token of the input will produce which token of the output. And after you have chosen the alignment function, then you will generate the output tokens by making the output y1 through ym be a function which is corresponding aligned x token. So a simpler case is when you are doing monotonic alignment, where each xi produces the corresponding yi, and here is an example. Let's say here I have an input x1 which consists of two tokens ae, and it is supposed to produce a token y1 which is like 3,8, where implicitly I have generated the data by saying that A maps to 3 and E maps to 8. There is a dictionary of mapping of tokens. It's just that I have arranged them so that there is a set of M keys presented, concatenated, and then followed by a sequence of M corresponding values. It's like you have, you present the dictionary in this kind of a concatenated form to the LLM. So this is how now the diagram would look like when you want to try in context learning on this synthetic task, and you want this true output y star to produce this true output, say for A, B, you will have to look up A from this sequence, and you'll have to look up the mapping for B from another example. And no single example wholly explains your problem. And so this particular task, if you want to get it done by current large language models, maybe for m equal to 2 it might work, but even models like Llama 3 with 8 billion parameters could not solve this task with monotonic alignment. When we tried to provide like this batch of m keys at a time with m increasing from 1 to 8, then the accuracy that we get for getting the correct sequence drops as we increase the sequence length from 1 to 31. So when the sequence length is 1, it's vanilla scalar classification task. This is like the key value mapping task, and that can be easily solved with LLMs. But if you want to solve to even m equal to 2, then you see a drop in accuracy. Okay?
Hello, Sivika. Yes. I have one question.
Right.
So I understand the need for you to go to synthetic regular expression languages, right, so that you can avoid the contamination aspect.
Right. Yes.
But even if you for a moment forget the contamination aspect, where for example, if you give examples of simple translations, right, like language to language translations. Right. So there the model, of course, the model has been exposed to these kinds of syntax.
Right.
But then even then, if you can make the task challenging for the model in terms of predicting y, right? That is, even though it knows the structure of x and y, which is the input and the output, the mapping that you induce can still be artificial in the sense that, so do you find that the models are struggling even when they know the structure of these x's and y's, but the mapping is not obvious.
Right, yes, good question. So this task, this is for synthetic, and after that we tried it for actual low resource language to language task, like trying to convert English to Tamil, for example. And we find that if you train it if you fine tune it, then it does much, much better than if you just give those examples in context. So it means that, okay, maybe partly it is learning the dictionary of which word maps to which other word. But although we were trying to mechanistically interpret whether it is also learning better alignment, that we have not been able to uncover, but that was sort of our hypothesis. Maybe we will try on more structured tasks. So basically what we found is that one of the main reasons why it may not be able to function is because it is not able to learn the alignment. Yes. So
just quickly, the alignment meaning, the A was 3 and B was 9, and the structured here, again, I'm trying to, sorry, naive question, but basically the probability, the joint probability is a product of the individual
simpler components.
Okay.
Right. Yes. Thanks, Varsha. This is very useful clarifying questions. So, suppose, so our main claim of why the LLM struggles is because it cannot understand that this token, first token here aligns with the first token here, which is what we are calling as alignment. And if you help the LLM by giving an X and asking it to produce the aligned sequence, then it can learn in context. Okay. So therefore, we found that this is a big problem. And this is an open problem we are trying to understand, that can you learn alignments in context? So that I don't think you can with current transformers, the way they have been pre-trained, you cannot learn alignments in context. So therefore, what do you have at your disposal if you really want to adapt a model for this structured sequence-to-sequence learning tasks? So over the last 1 year, we have explored 3 different methods which apply in different settings. So the first approach is to actually do fine-tuning anyway, but to not do the conventional fine-tuning. Normally, when you do the conventional fine-tuning, you train the model to minimize loss. You give one sequence and you train the model to produce that output sequence Y. Instead, what we are proposing is that you should be even fine-tuning in the in-context mode. So it's like in-context fine-tuning. Even at the time of fine-tuning, you give always like a set of related examples in context, and then you minimize the loss on a target sequence. When you do fine-tuning always with examples, the model learns the in-context capability, and that provides better capability of out-of-distribution generalization. So I'm going to skip details of these graphs, but I'll just quickly talk about this very interesting mechanistic interpretation we did to uncover what is happening. So here you see we were doing fine-tuning in context mode. Here you see different training steps, and on the y-axis is the accuracy of alignment. You can check the attention heads to see whether the Y tokens have correctly aligned with X tokens. What we found that across different layers of llama, so llama has like 21 plus layers. So here are the higher layers which are in blue, and the red ones are the middle layers. So the middle layers learn to align. Once the middle layers learn to align, then along the same training step, on this y-axis here, we are showing the lookup accuracy, like are you able to look up the correct value from previous examples or not. So the lookup accuracy emergence is in higher layer, and that happens right after the model learns to recover alignment. So this basically, whereas if you don't do fine-tuning in the in-context mode, then alignment is not learned.
Sorry, one more clarification. So fine-tuning in context mode means the supervised examples for the fine-tuning are those in context examples.
Right.
Okay.
For every example, like normally you would just pick one sentence and try to predict its target. Now one sentence will always come with k other companions.
Few shots, yeah.
So this is one method, but of course fine tuning is not always an option, and we have been working on 2 other methods. And in fact, the good news is, even though I will not be able to cover it, my students will be presenting posters on these 2 other more practical methods of adaptation which you can use on real tasks. So first method we are proposing is that sometimes for some text to code task, if you have a very large code, then maybe you can snip and decompose that large code into smaller pieces, and there are some technical challenges on how you do that decomposition, and with that you can avoid the problem of burdening the LLM to uncover the alignment and to find out which subpart is relevant for your target question. That is first thing that we do. And the second thing, which is also a poster here, we try to do sort of, you use an external module to do more fine-grained reasoning about the relatedness of 2 examples. This is like reminiscent of the matching-based methods which were used earlier, and with that we are getting significantly better accuracy than in context learning. And in fact, this last item is what prompted the title of my talk, which is Beyond in Context Learning. So this is the part about where we decompose, like say, so Varsha, you wanted an example. This is another example. Let's say here there is a natural language question which is used as a scheduling assistant. Schedule a team meeting tomorrow from 3 p.m. to the end of the day. Now the corresponding API call for this natural language query is this Lisp-like program. Now this program has a kind of a structure which we can easily analyze with the help of programming languages people, and we can break it up just in the structured space into code snippets which are standalone complete code snippets. Now this gives us several more training examples which are smaller and more focused, but though these code snippets by themselves are useless unless they are accompanied by the corresponding natural language utterance. So then in the next step, we attach with each code snippet natural language utterance, but these are not independently generated from the LLM. That would be the obvious way. That does not work. What we try to do is generate this sub-utterance, this utterance, so that it maximally reuses the words from the original natural language query. So with that, we have natural looking sub-questions attached with sub-programs, and this gives us an augmented training pool. And when we sort of use these decomposed programs, we get higher accuracy, particularly when we are trying to generate for low resource languages like Hindi and Russian and all that. I mean, low resource depends, is a function of LLM. For some LLM, Hindi is not low resource, but yeah, you understand. Then the second point is about when we try to use, yes.
Sorry, I didn't understand the connection of this approach to low resource.
So it's like here, what we try to do is generate the API calls with function names which are, say, in Hindi. So instead of saying, so like often if your browser goes into Hindi mode, you get these command names like file khol do, those kinds of things. Okay, yeah. So when we do that, we find that you learn, you really benefit from such decomposed generations. Then the third thing is about a more sort of focused reasoning about relatedness of example. So this is, we try to use it for this task of in-context learning for text to SQL generation. So normally when you use in-context learning for text to SQL generation, you will have a schema, and then you will provide natural language question and the corresponding SQL. Let's say here we are providing 2 examples in context, and you provide your test question. So these are real test questions. We have not modified anything. So in this test question, this part might look slightly unnatural, but that is how it was. And now you ask for the answer. So if you have already been fast, this constant here is different. You just have to replace the name of the molecule. And we find that even in this very simple case, many of the large language models fail to copy over a full SQL program from the context modulo some constants. Okay, so that failure was a bit disappointing. So we propose a more elaborate fix, and that we can go to the poster and hear from Smith and Sarvam on how we solve this problem. There is a very interesting part which is more broadly applicable beyond our problem, which is you can, when you are using LLMs to generate structured output, very often you might want to make sure that at least the generated code passes the parsing, the grammar tests, so it's accepted by the grammar. And with that, you can modify the LLM decoding algorithm to generate tokens so that they are syntactically valid. So we use this grammar constraint decoding to force an LLM to copy over most of the structure from a highly related prior example. And that produces huge gains compared to in-context learning. So over 2 LLMs and 2 data sets compared to, say, in-context learning on a small, like, say, text to SQL model where 3 examples just gave us 50% accuracy. With our more elaborate reasoning, we are able to get huge jumps in accuracy. So I will conclude. So in-context learning, it's very convenient for on-the-fly adaptation for multi-tenancy models. Its accuracy is decent for at least some of the easy tasks like scalar classification, and its robustness requires improvement, but it is improving every day. And efficiency, it can be high. And if you have a large number of examples, you have to worry about the KV cache, how to do self-attention over a quadratic set. And that, there are, speaking of research topics, an interesting research topic is how can you efficiently look up a large number of in-context examples which you want to pre-encode and store as KV cache. And but more work is needed to understand why in-context learning works, and only when we understand can we fix it. And then another another conclusion is that for totally unseen tasks, which are like made up synthetic tasks, LLMs do a very good job for scalar tasks and also for learning Markov languages. And these induction heads, I didn't have time to go over. That is the technology which enables you to learn new tasks on the fly. But it fails for unseen sequence-to-sequence tasks because input-output alignments cannot be learned in context. Okay? We have for informal conjecture that it's not possible for the transformer self-attention causal architecture to learn alignments. Okay? So we want to come up with a hybrid. So we came up with a hybrid of in-context learning and fine-tuning, and that better encourages the model to actually uncover the structure between input and output sequences. But when fine-tuning is not an option, then you have a bunch of things you can do. First, you can maybe decompose your large structured programs into smaller components, and there it's very useful to attach with each code snippet natural-looking natural language annotations. And then the other is to do a template-driven representation of the in-context example so that the LLM is not distracted by matches of constants. So essentially, you are generalizing the examples beyond the surface form, and that helps the LLM to do better reasoning. And we found it very useful to have our own external matcher over pairs of examples. You can get to know more about it from Smith and Sarvam's poster. So I'll conclude. Right, yeah. So, okay, so maybe I'll stop here and you can read the open questions. And this was my last slide. Thanks. Yeah. Yes, yes.
Hello. So first of all, thank you for this wonderful session. My question is that recently we have news about large concept models. If you quite have news about it.
Oh, actually, I don't know what a large concept model is.
Yeah, there is a research paper in Meta that there is something called large concept models, which works on the similar like generalization problem of few shot learning and all that. So I was just wondering that if they are both connected with each other or not.
I will have to read up about large
Yeah,
concept models.
in the paper they have said that that around 7 billion parameters they have exist like they have more performance accuracy in 10 existed models with that.
Sure, I will take a look. Thanks.
So just I have the question about that large concept models, are they
Yeah,
equivalent?
since I don't know about them, I
Okay.
cannot comment.
Okay.
Yeah.
Thank you.
Yeah. Yes, Sharath. Yeah. Maybe we should give priority to students first. Yeah.
I see. So thank you very much for a very interesting talk. I just heard of sort of a big picture question. If you look at traditional computer science versus LLM, it seems like LLM was closer to
Mic. Podium mic test. Podium mic test. Podium mic test. Okay.
Hello, hello.
This is just a pre-formal announcement again about the mics. First of all, the mic volunteers, please stand in the middle, okay, and face the audience so that you know who is going to ask the questions after the talk. And it will be nice if the people who want to ask the questions raise their hand while the other question is going on. Then the mic can be brought to you in time, because all of this, if we can record the questions, that will also be nice. Okay, thank you. Bio, who's doing the MC? I put some year and all of that in it. Who is doing? You? Just added year or something. Other than that, it was fine. Actually, so we can share now, no? Anit was okay. I will share. We are especially to do last minute. We will finish at 3 o'clock. 3 to 3:30 is the break, is it? 2:45. What is that? 2:45 to 3:30 time. During that time, I think so we can. It will go till 3 probably.
Yeah, because it's already 10 minutes. Okay. And this minutes cards are like remaining minute or remaining? I came in the morning, I saw it was full during so
yeah, this time there are interaction, even during mentorship. Well, amazing organization with every PhD. I was looking at tables to see if there was going to be nobody from IIT, but every table I saw somebody. So very good job. Excellent. Student talk, by the way, I'll send another reminder today. Strong feedback coming there. It takes a lot of expertise to reduce. Do not bother. It takes a lot of humility to just forget about your contributions and make sure that your field is. It's not recorded. It's correct. Just basically motivate, na? Motivated, gave the setting of the problem. End with what are the problem. That's another reminder for many tables I got this week. Sunita spoke also actually, too deep. It's okay. Millions, I think everybody has appreciated.
Mic volunteers. But where is that list? Morning it was Ameya and Rohit, no? Are they still not the same people?
I think girls are
Welcome back, everyone. I hope you all had a very good session in the morning with all the faculty talks and the student talks. Right now, in the second session, we will have two expert talks followed by a panel discussion. And after that, we will have the poster presentation in the CC. So right now, we have Vrinda Dave, Dr. Vrinda Dave. She's actually an alumnus from the institute itself. So she received PhD from CSE Department IIT Bombay under the guidance of Professor Krishna. She received honorable mention for ACM India Doctoral Dissertation Award of 2022 and an Excellence for PhD Research Award from CSE Department IIT Bombay. She was also a finalist for the E.W. Beth Outstanding Dissertation Prize of 2022. And she is currently an architectural formal verification engineer at Intel. So today she'll present her work on the theory of string transformations, followed by avenues of the use of formal verification in the industry. So please welcome Dr. Vrinda Dev. Thank you.
Thank you. Thank you for the introduction. Yeah, hello everyone. Good afternoon. So I'll talk about our work on string transformations, and also we'll talk about how FP is used in formal verification is used in industry. So this work is jointly done with Professor Krishna. So I'll first talk about string constraint and the problem of separability for string constraint. Then I'll briefly talk about string transformation, string transducers, because our results uses automata theoretic relations. And then finally, I will talk about formal verification use case in hardware industry. So recently set 10 SMT solvers are heavily used in industry, and actually it's an active research area in industry as well as academia. So simply if I take a base case, so consider this Boolean constraint which says that P and Q or R evaluates to true. This P, Q, R are variables which can take values or true or false Boolean values. So to make this equation to be true, there can be multiple satisfying assignment. One of them is listed here, that is if we take P to be true, Q to be true and R to be false, this whole equation will become true. So this is about Boolean constraint. If we extend this theory with strings, so it is called string constraint. Simple example I'll give here first, and then we'll look at formal definition. So this is a very basic string constraint which says x equal to ay. Here x and y, these are unknowns or variables, and a is a constant. So if we assign x to be ab and y to be b, we can say that this constraint is satisfied. Okay. And another kind of string constraint can be membership constraint. That is variable x belongs to some language or regular expression a star b star. So if we take x to be ab or a, ba or any word which starts with a and has b as a subword in suffix, then it will satisfy the constraint. So this string constraint is actually being used in industry. AWS uses string constraint to assure their customers that their policy, access policies are what is intended to be. That is not, the person who does not have access should not get an access. So for that, they are using the string constraint, they are encoding their access policies into string constraint and passing it to solver. Okay. Yeah. So I will now formally define string constraint. It's inductively defined. So using atomic constraints. One kind of atomic constraint is membership constraint, what we have seen as an example. X belongs to some regular language L. So for example, X belongs to AB star. AB star is a regular language. And it can have multiple satisfying assignment, like AB is a satisfying assignment, but ABA is not, because it does not have B paired with last A. And the language of a constraint is set of all satisfying assignment. So here there is only one variable X, and all satisfying assignment will be of the form AB raised to n, where n ranges over natural number. So that becomes the language of the constraint. Okay. And another kind of atomic constraint is relational constraint, where we can define relation between two terms. Term is nothing but a sequence of constants and variables. And this relation is definable using input-output automata. So I think most of you must be familiar with finite state machine, where we have finite number of states, transitions between them. If they are labeled by input as well as output, it's called transducer. Here is a sample example which has two states, one initial state which is indicated by arrow, one final state, and what it simply replaces A with B. The left side of the slash is the input, right side is the output. So it replaces A with B and B with A, and it accepts the string if it has even number of B's. So this is the simple transducer. And suppose our constraint is xy belongs to this transducer, or basically when we evaluate the assignment for x, if we run through t, then we get the valuation of y. So sample valuation is given here. If x is a, b, b, y will be b, a, a. And here the language of this constraint phi will be a two tuple words, because there are two variables. Okay. Formally defined as string constraint is formally defined as conjunction of both of this kind of string constraint, that is membership or relational constraint. This is a simple example. It says that, yeah. Okay, yeah, sure. Yeah. It simply says that x has even number of A's, y has even number of A's, and x and y are related by the transducer, what we had seen in the previous slide. Okay. So now any constraint language, the most burning question is whether given a constraint, does there exist a satisfying assignment for that constraint? It's called satisfiability problem. And this string constraints are heavily used in sanitization of database inputs. There is this funny comic which shows that if we do not sanitize our database input, then it can lead to disastrous situation. Okay. Yeah. So yeah, let's see some results, history about string constraint, what work has been done in this area. The satisfiability problem easily becomes undecidable for general string constraint, because we can encode this famous undecidable problem PCP into the simple string constraint, that is x belongs to R. So decidability is like whether given any string constraint, can we answer whether it has a satisfying assignment or not? That is the question, decidability question. Okay, so it is, so given any constraint, we cannot, there is no algorithm which given any constraint will say if it is satisfiable or not satisfiable. Okay. So people have tried getting decidable subclasses for which the satisfiability is decidable. So one such subclass is straight line fragment. So string constraint, if there is a dependency on, what is dependency here is that if we write x, y belongs to R, that means y is dependent on x, because to produce y, we should know the value of x. So if we do not allow cyclic dependency, that is like here there is cyclic dependency, x belongs to R, then that fragment is straight line fragment, and it is shown to be, the satisfiability for this fragment was shown to be decidable, and future work has been done for that. Another well-known subclass is length preserving. So here the cyclic dependency is allowed at some extent, That is x1 depends on x2, x2 depends on x3, x3 depends on x1, like that. But the restriction is on relation, that relations are length preserving. So that is, the meaning is that whatever the length of x1's valuation, the same length should be preserved for x2's valuation, and so on. So relations are like one to one or letter to letter. So now we will look at another problem, separability problem, which will help us decide satisfiability of some of the string constraints which are not from the known subclasses, that is straight line fragment or length preserving fragment. So this will help us decide satisfiability. So let's see what is separability problem. Given two constraints, phi1 and phi2, it asks, does there exist some separating language which separates L phi1 and L phi2? What does it mean is that there exists a superset of L phi1 and which is disjoint from L phi2. So if that such separator exists, then we are sure that phi1 and phi2 conjunction is unsatisfiable. That is, there is no satisfiable assignment for phi1 and phi2. Formally, if phi1 and phi2 comes from class C and separator comes from class S, it's called S separability of class C. So in one of our result, we have shown that any string constraint phi, given any string constraint, general string constraint, we can construct two straight line fragment constraint, phi1 and phi2, such that they are equisatisfiable, meaning that if phi is satisfiable, then phi1 and phi2 conjunction is satisfiable and vice versa. So if now for this phi1 and phi2, if we check for separator, if there exists a separator, then we are sure that phi1 and phi2 is unsatisfiable. Yeah, please go.
So with respect to the separator and L phi 2, you are asking the same question as you are asking for L phi 1 and L phi 2, that they are not overlapping or something, that's different. Is it the same question that you are asking for S and L phi 2 as you are asking for L phi 1 and L phi 2?
The question is about phi1 and phi2, that does there exist such S which is a superset of phi1 and disjoint from phi2?
Yeah, I'm trying to understand why are you asking that question. Does it make it easy for you?
Yes.
Otherwise, I'm not understanding why this question is relevant.
So because in general, we do not know the answer whether if given any phi1 and phi2, if it is satisfiable or not. There are some fragments for which this answer is known. There are algorithms. But there can be, for example, simply if we take these two constraints, xy belongs to R1, y belongs to R2, the first one, both are, there is no cyclic dependency. But if we take conjunction of P1 and P2, there exists cyclic dependency now.
Okay. Okay.
Constraints, if we can get separator, we can say that their conjunction is unsatisfiable.
Okay, thanks.
Yeah, and so these from now on, these are our results, which are done in collaboration with Parosh and Fauzi. We have shown that if the separator class is a regular language, then regular separability of string constraint is undecidable, as well as straight line constraint, it becomes undecidable. So we have now explored another separator class, which is piecewise testable language. Why we used this class is because this class is heavily used in language separability. There are multiple results about PTL separability of different kind of languages. In formal language, we have many different languages like regular language, context-free language, multi-push down language, and so on. So for all of them, this PTL separability is well studied. So for our usage also, we use help of it. And piecewise testable language is a Boolean combination of piece languages, which is of the form sigma star A1, sigma star A2, sigma star AN. So basically, it says that there is a subword A1, A2, AN. And then such languages, if they are connected with union, intersection, negation, then it becomes PTL class. And we have shown that the separability is decidable for this class, but it uses, at some part it uses algebraic proof. So because of that we could not extract the complexity here. So I'll show one part of this proof, which is basically encoding of solutions of straight line fragment to ordered multi-push down automata. So don't get afraid of these names. So first let's see what is it. So push down automata, maybe you know that it's a finite state machine with a stack as a storage element. So we can push and pop from those stacks. At the top of the stack we can push and pop. Now MPA, so multi push down automata is where we have multiple stacks as storage element, and ordered multi push down automata is that the stacks, multiple stacks are there, they are ordered, and we can do the pop operation only from the non-empty stack, from the first non-empty stack, sorry. So because they are ordered, we can say that from the first non-empty stack we can pop, but we can push in any stack. So that is ordered multi push down automata. So I'll quickly go through this encoding. It's interesting to understand this. So suppose the constraint's general structure is like this. It's a conjunction of membership constraint as well as and conjunction of relational constraints. So let's say xi is our variable, ti our term, and straight line fragment has this restriction that xj appears in ti, then j is greater than I. So dependency is over higher index variable only. So xi is the output here, ti is the input. So xi is dependent on variables which are higher than it. Okay. So we will construct one ordered multi push down automata which will satisfy ti xi belongs to ri. It uses linear number of stacks. So this is what we want, that initially we have suppose valuation of xi plus 1 to xn in our stacks. At the end of computation of AI, that is constructed OMPA, we want to get valuation of xi, okay, which satisfies ti xi belongs to ri. So this is how we'll go about it in phases. So in first phase, what we will do is that we will pop the contents from first n minus I stacks and push this contents in next n minus I stacks. Simple. And at the end, we will get reverse of each valuation in this second n minus I stacks. Now in the next phase, we will again pop from this n minus I stacks and push the contents in the last n minus I stacks, as well as during this process, we will also push the values of this variables if they are present in ti into this stacks, the third set of stacks. So, okay, first we popped and pushed the elements in n minus I stacks, last n minus I stacks, and parallelly we have also updated this ti mod ti stacks, which will contain the input for to generate xi, because they are only dependent on variables which are higher than xi in the index. Okay. So this way we got the valuation of ti in this third set of stacks, and now I think it's easy to understand that we will pop from this ti stacks and run the transducer for ri and get the valuation of xi. And this valuation what we get is pushed into this stack, the fourth set of stack. So this will get us reverse of xi which we wanted, and in the last phase we will just pop from this stack and push into this stack. This will become xi which we wanted. Okay. And this can be repeated for all the constraints, all the variables xi which have relational constraint, and this kind of OMPA can be concatenated. Now we have seen that how to satisfy this constraint using OMPA, but we have not taken care of membership constraint. So now at the end of this OMPA construction, we will have valuation of x1 to xn in the stacks. So we will pop the stacks one by one, read whatever was there, and simulate the corresponding automaton for regular language. and see if it actually belongs to that language. So at the end, we will have language, and while doing this popping, last popping, we will read hash in between when we jump from one stack to another stack. So at the end, what we get is that if E is satisfied by some satisfying assignment W1, W2, Wn, then the language of OMPA will contain W1 hash W2 hash Wn. And this is like if and only if. If OMPA contains this, then it should be a valuation of phi. So that is our result, that we first show that PTL separability of ordered multi-push down is decidable, then we encode the constraint solution to OMPA language, and then we show that the separability at both places is same. Basically, if formula are separated, then automaton are also separated. So why I discuss this is that the problem we started with was practical, but the solution required theoretical understanding, because we had to go through ordered multi-push down automata, encoding, and also like this proof of PTL separability. It uses other results from algebra. So it's like a problem will come from practical perspective, but to solve the problems, we might need a bit of other areas as well. Automata, logic, in theory I am talking about, automata, logic, algebra. So this kind of practice will come from, or this kind of understanding will come from practice. We have to read papers, go into research, we talk to people. That way we will get an idea gradually. Okay. Time is there. Okay. Okay. Yeah. So for time, yeah, I'll quickly talk. I'll not go into detail, but we have also explored another separator class called POS-PTL. So it is a positive Boolean combination of piece languages, and we have shown it to be decidable. So for that we have very elegant proof which says that two languages are POS-PTL separable if and only if upward closure of one is disjoint from another, or if and only if downward closure of one is disjoint from another. So yeah, it's quite simple. We have made it quite simple. So, and yeah, we have also define another set of another subclass of constraint. We call it right-sided SL constraint. So it is such that there are some independent variables, and all other variables are directly dependent on it, and it can implement all straight line constraints with functional transducer. It is fairly practical subclass because it contains all functional transducers. And for this particular result, we have taken help from transducers, two-way transducers we have. So actually my PhD topic and my previous work was fully on transducers. So when this question came, it became somewhat like intuitive that we can use transducer for this to solve this problem. And we have shown that it is decidable in X space. Okay, then I'll quickly, due to time constraint, I will not go into detail of this proof. We can talk about it later during break if you want. So yeah, shifting gears. So now I'll talk about some industry application from formal verification. So I work in hardware industry, and there formal verification is largely used. So any product or design goes through product life cycle, including starting from whiteboard phase, architectural idea, microarchitecture logic, design, synthesis, silicon. And nowadays it has become like mandatory to get formal verification sign off for this part, that is design. And this design is done in hardware language like system Verilog. So there exists some tools, vendor tools, which can take input as this code, Verilog code, and there we can write properties which are based on linear temporal logic. The tool will take that property and actually check this question. This is like model checking is central question in formal methods. It asks, given design, I mean, does my design, does it satisfy the intent, that is specification? So the same problem is asked here in hardware industry, that given this design, does it satisfy architectural idea? Okay. Sorry. Yeah. So yeah. So even after, I mean, there is lot of research in set solvers, model checking. After years of research also, there is always scope of improvement, because still our designs are not scalable by those tools. And we have to use abstraction technique to get the convergence, or sometimes we have to be happy with the bounded proofs. So for that, I think this is where academia and industry, if they come together and try to get some solution or improve, for improvement there is always a chance. Another work which is in hardware industry only. So yeah, we saw this life cycle. So currently here the formal verification has become mandatory, but if we push it or do shift left, that is we can do formal verification here or here, then the issues which can be caught, that will not go into further cycle. So it will save a lot of time and human effort. So basically nowadays it has become, recently it has also started architectural formal verification. So for example, I'll give you a very basic example of it. It is very popular in protocols, cache coherency protocol. So if there are n number of caches, they all want to access memory, and there is this memory is guarded by some homing agent. So caches will send request to home agent, and home agent will get the memory and give it to cache, or I mean do something such that cache will have access to it. So here again for architectural formal verification, it has challenges its own. So it does not have design available. So whoever is doing it has to model the design and then pass it to some model checker. Tools are still, I mean, some tools are not scalable yet. So if we go from these models are parameterized. So we have multiple different parameters, and like number of caches, number of buffers, and so on. So if we increase the number of caches, sometimes it is not scalable, the proof will not converge. And there are so many, since there are many parameters, there will be so many configurations. How many configurations to check? There are two issues. Like if there are many configuration we think, then we may not have time, deadlines are approaching. Or it is not even feasible by a tool, because sometimes if we increase cache, it becomes non-convergent. So for that, if there is some mathematical intervention which says that we have to only verify this set of configuration, or if we can say that if we verify the system for 3 caches, we do not need to verify it for 4 caches. So there some mathematical abstract ideas can be used to, so those kind of problems are quite interesting there. So yeah, these are the problems in industry. So yeah, with this I'll conclude my talk. Thank you so much. I had, yeah, I was fortunate enough to work with very good collaborators, my guide, and I wish all of you to have such wonderful journey. And thanks for inviting me. Yeah, any questions I can.
Thank you. This was a nice talk. So I have some background in programming languages and coding and so on. So I do some work in that space. So one of the biggest challenges that we find is more than verifying, even writing the specification compactly, right? That seems to be often as challenging as verifying.
Yes.
So you had, in your figure, you had two places where you said you can introduce verifiers, right? So
yeah.
how do you think about specification problem here? Like, is it can
It
you
is one of the challenge because we do not have design available, so we have to write the code. Whoever is doing modeling should be confident enough that whatever model he has written or she has written should be what is intended to be. So yeah, there are various ways to formalize the specification itself using tables or diagrams. But at least in my experience, I have not seen any complete method. Tables are still formally, I mean, it is currently used and it's kind of formal because it's a complete thing. We can visualize it. But the diagrams, in my view, it is not, yeah, I mean, people say that it can be one of the good way to formally represent specification. Yeah, it is, so these two are formal representation for specification.
Thank you.
So that's what your question was. Okay.
Participants, please ask if you have any basic question, something you didn't understand many slides ago also. Please feel free. This is your moment. You traveled all the way through the country to ask questions.
Hello, ma'am. So I have an electronics background, and I know how to write Verilog code and everything. And we have been taught to use Cadence and Synopsys tools like that for verification. So right now, what we discussed about string constraints and all of that, I wanted to know: is this what is going on in the background of those tools during formal verification? Is this what goes on? Because we never understand what goes on in the back end of those tools.
Right. Yeah, they are all confidential things. I mean, even I am not from Cadence or Synopsys, so I don't know. But I suppose, yeah, that's what in the back end of the tool, there is model checking algorithms, set solvers, they are present there.
So my follow-up question is, formal verification in the hardware industry, where exactly is it used, and what does one do to get a role in that?
Yeah. Currently, it is used at this stage to formally verify the design.
Correct.
And in most of the companies, it has become mandatory to do formal verification at this stage. And in some companies, it has also become like not mandatory, but it has started to do formal verification in these areas, that is architecture and microarchitecture phases. So yeah, I think your question was what to do for, I think understanding of logic is, in my view, it is required to solve this kind of problems. And yeah, that's linear temporal logic is also one of the thing which you can learn to get a chance there.
Thank you, ma'am.
Thank you, Professor. Thank you, Dr. Vrinda, for the fantastic talk. May I request Professor Varsha to give a... Okay, may I request Professor Purushottam to give a token of appreciation to Dr. Vrinda? I think that one, or I don't know if they're different.
Oh, sorry. Thank you for inviting me. It's always nice to be back at IIT. Thank you.
Yeah. The next talk will be delivered by one of our own faculty members, Professor Sayandeep Saha. His research focuses on hardware security and cryptography, and he has expertise in fault attacks on symmetric key and post-quantum crypto systems. He also explores side channel attacks, microarchitectural vulnerabilities, and logic locking. Professor Sayandeep received his PhD from IIT Kharagpur in 2021 and was a postdoctoral researcher at NTU Singapore and UC Leuven in Belgium. He has joined the faculty at our department in 2024. Today, Professor Sayandeep will talk about the journey to the post-quantum cryptography with an informal introduction to lattice-based cryptography.
Hello. Okay, from here to here? Okay, great. Fine.
Any of the panelists, if they are here already, you will have to probably miss this talk. Panel is at 3:30, right? Panel is at 3:30. Can you meet me outside the auditorium and we will go to some room and just discuss the panel a little?
Yeah, just show it.
I'll just go.
30 minutes,
I will
right?
wait outside. So I don't know who all. I guess Vrunda, Shivram is here. So yeah, let's just meet outside. Thanks. He'll come. He's at 3.
Okay, I hope I'm audible to everybody. So, welcome to this talk. The title is A Journey to the Post-Quantum Cryptography, and I think this is the last talk in today's session, last faculty talk. So I will go very informal, very slow, just like stories, what we have seen, okay? So you can see multiple buzzwords over here, post-quantum cryptography. So how many of you have heard of the word cryptography? Please raise your hands. Wow, great, good number. And how many of you know what is post-quantum? Still good number, very good. So let me first introduce myself. You can match me with the picture. So I'm an assistant professor in this department, recently joined, and my broad research area is hardware security and cryptography. Yes. Okay, so I'm not a theoretical cryptographer. So what I do, I break crypto system in real life when it is running on some device and extract their secret key. And I also sometimes fix them, but I don't like to fix, I like to attack more. Okay. So this talk is not on a quantum computing, okay? So I'm not going to talk on nice quantum computers and all. This talk is on cryptography, which will withstand attacks from quantum computer. So those who know cryptography, but still just a recap, that in cryptography the classical model is something like this. There are two persons, Alice and Bob, they want to communicate. And say Alice is sitting in Miami and Bob is sitting in Mayapur. So they have to use some communication channel and they don't want anybody to read that message, okay? So what they will do, they will have to set up algorithms, some magic algorithms, and they have secrets. So the secrets are shared between them. And based on the secret, Alice will encode, or we call it encrypt, his message, and then send, and only Bob can decrypt the message or decode the message and read it. That's the main premise of cryptography. Now, what is special about that? that it is not an ad hoc thing, it's not an art, it's a science, it's a science. So what we do, we give some mathematical guarantees that okay, nobody can break it. So how do we give the mathematical guarantee? I will come back to that, but before that I would like to mention that whatever is going on in this room is involving some form of cryptography. If some of you are doing WhatsApp, that's end-to-end encrypted right now, okay? So cryptography is very important at this point, and it's so crucial that not only our nation states and governments, but all the big companies these days, like you think of Amazon, starting from Google, everybody is investing quite a huge amount in developing this subject. So it's a very exciting subject actually. So coming back to the mathematical guarantee, so everything starts from there. So we argue the cryptographic security in this sense, that if you can break my crypto system, my algorithm, then you can solve some hard problem. Okay, and hard problem means it's really hard. We do not know a polytime algorithm for that problem in computer science. It's that much hard. So yeah, if you can break that, my crypto system in some sense, you might get a Turing award because you will be solving a hard problem in that case. So like that. So therefore, you can assume, you can understand that this system is pretty secure because these hard problems are being studied for years, centuries in some cases. Okay, so you can say that they are pretty hard. Now again, coming back to just what cryptography does, so it does very basic things. There are two paradigms. One is, it's called symmetric cryptography. There, both sides are sharing the same secret key, same secret material, okay? And another one is public key cryptography. It's a bit unique because one party generates two keys, one public key and one secret key. He keeps the secret key with him, like here Bob is keeping the secret key with himself, and he distributes the public key. So if somebody like Alice or somebody else even try to send a message to Bob, which he intends only Bob can read and nobody can read, he will just encrypt the message with a public key and send it to Bob, and Bob can decrypt the message, okay? So only Bob is able to decrypt, but everybody is able to encrypt. That is the premise. So it's clear, I hope, to everybody. Okay. So now, both symmetric cryptography and public key cryptography are based on some form of hard problems or hard problem assumption, better to say, because nobody knows whether they are really hard or not. It's just we have not been able to solve them yet. But symmetric cryptography has a different set of hardness assumption, and public key cryptography has more number theoretic or mathematically established assumptions of number theoretic assumptions. So whatever is used today, most of the public key are based on two classical algorithms. One is RSA and one is elliptic curve cryptography. So RSA, how many of you have heard the term RSA? Quite good. So if you see RSA, although it's a bit of sweeping statement, but you can say that RSA is based on one hardness assumption, that is you cannot factor large integers, okay? So if you are given say I am a person, I have two prime numbers, somehow I figured out two big prime numbers, I just multiplied them and I give you the n, okay? And I ask you, can you factorize n and get me p and q? That's a terribly hard problem actually, okay? That's pretty hard. And it is known from like years or centuries. Another form of cryptography, that is elliptic curve cryptography, which is vastly used in modern internet. So you can ignore the fact what is elliptic, what is curve for now, but let's see the problem. It's called elliptic curve discrete logarithm problem. The problem is that, again, you are given q and p. They are two different things, and where q equals to x into p, it's a multiplication. And you have been asked to find out x. It is also known to be a very hard problem, okay? And q or p are basically points on the elliptic curve. So elliptic curve is a very weird looking mathematical object, and again we make it more weird by defining it on a finite field or ring. Then this is very hard problem, it becomes very hard problem, even hard to describe, you can see, and actually it's a hard problem. Okay, cut to 2025. So these things are there for like how many, 30 years from now? Yeah, 30 years. So now my question is that, are these assumptions still valid, this hardness assumptions still valid? The answer is indeed they are, but depends on your viewpoint or your computing power rather, okay? So in 1994, a person, a very great scientist from AT&T Bell Lab, came up with an algorithm, which is one of the first quantum algorithms described so far. And he showed that he can solve the factorization problem for a prime n in order of log n cube time. Yeah. Now I think there is a slightly better algorithm, but this is kind of well known. And then I think after few years, it's not few years in fact, this is just a like extension of this work. This date is not the exact date, it's a reprint date. I think in 3 or 5 years, they came up with another algorithm for solving discrete logarithm under the same principle actually. Now see the change here. So here you can solve it in order of log n cube time. So n is the number, it's not the size of the number, it's the number. And otherwise with a classical computer you can solve the same problem, you can try to solve the same problem, the complexity is sub-exponential. So typically with classical computer you cannot break this kind of factorization, so you cannot break RSA. And with quantum computers you can break it extremely efficiently, that is the perspective. And then ECC is also broken, okay. So what does that mean? That means whatever you are doing now, okay, you are not secure. If the quantum computer arrives, whatever you are doing right now will be broken and everybody can read your message, whatever you have done so far, okay. So be careful. Okay, so now coming back to the reality again, this was theory, brilliant, beautiful theory, but where the quantum computers are now at this point. So right now I think in 2025, please correct me if I am wrong, if there is some quantum expert here, I think IBM Condor has the highest number of qubits, 1121 qubits. But now the question is that for breaking practical RSA that are used in internet these days, how many qubits you require? The answer is you require millions of qubits actually, and we are still not there. But, and why millions of qubits? Because basically RSA, modern RSA that are used in internet is either 1024 bit prime or it's 2048 bit primes, it's pretty hard to break. But why millions of bits? Because quantum computation is, I mean, qubits are not perfect, they are erroneous. So you need a whole lot of error correction, for that you need extra qubits, so it becomes quite a millions of qubits. But you might say that, okay, I mean, that will be reached like after 30 years, 40 years, or I don't know when. But the estimation right now, the way quantum computing is progressing is 2019 to 2025 and all, NIST, the National Institute of Standard Technology in US, they predict that by 2030 or 2035 we will reach that capability. So actually we are in danger. Now again you might say that why do we need to bother about right now, right? We are still in a safe world. And should we really bother about spending millions and billions of dollars behind, developing some quantum resistant cryptography and all? That's a prudent question. The answer is that it is the time. Why? Let me give you a very small example of attack. Say there is some rogue government or maybe a rogue person who is simply, getting a lot of data, encrypted data from internet and simply storing it in his Google Drive or some space, okay? When the computer arrives, he readily decrypts that and then he can blackmail the entire world almost. This is a huge possibility and people are scared about that. So those who know George Orwell, so there was a famous quote by George Orwell, those who control the past control the future. So that's it basically. You can control the future in some sense. I think it's this one. I got it from somewhere. Yeah. So again, another possibility is that there is some cryptographic application called digital signature. So how many of you have heard of that, digital signature? Wow, good, very good. I have a good audience. So in digital signatures, you are a person who signs something and nobody can forge that signature typically, okay? So since nobody can forge that signature, you cannot forge a document or you cannot bluff somebody, right? But when the quantum computer arrives, you can forge all the classical signatures. So that's a big trouble, big trouble that you can see over there. Now the question is that our things are doomed, but do we have a solution to that? and we have something. Okay. So you see, you observe that the problem is basically not from the cryptographic construction side, it's the problem of the hard problems, because hard problems are broken, that's why your cryptography is doomed. So why not search for new hard problems? Okay. So searching for new hard problem is again a hard problem, I would say, not that hard but hard. So why? Because in cryptography, so those who are familiar with hard problems, they might think, okay, I will pick any NP complete problem and work, right? But the problem is that you cannot work with that. So NP complete problems mostly bother about worst case hardness, but here you need average case hardness. That is the first point. Secondly, you need something called a trapdoor. So the problem should be easily solvable on one side and hard to solve in the other side. So for example, if you take the factorization like multiplication is very easy, right? But reversing the multiplication, factoring is hard. So you need this kind of a property, it's called a trapdoor. So not every problem gives you a trapdoor, and then these problems are typically not NP complete, they are NP intersection co-NP in some sense, but that's okay. Fortunately, we have a lot of such very interesting, very nice hard problems, which are quantum hard in fact, okay. So there is a cohort of this problem, and for every problem we have nice algorithms from the community. And yeah, so using this hard problem, if we can construct our crypto, we'll remain secure in the quantum world. So in this talk, for the sake of time, I'll only talk briefly about this first problem, lattice-based crypto, and there is a reason why I'm talking about lattice-based crypto, because in 2016, NIST started the competition for standardizing the post-quantum cryptography. And you know, like whatever NIST says, I mean, after that, the entire world will follow that. So very recently, in 2023, they have selected the first cohort of algorithms, okay, and they are still selecting. 5 days back, they standardized another one. But the first set of algorithms, which are the most popular, is crystals Kyber and crystals dilithium. They are both lattice-based algorithm. One is for signature and one is for public key cryptography, or we call it KEM in some sense. There are other variants, but these are the most popular ones. So it makes sense to learn a bit about lattice-based crypto. And just before going to the math, let me tell you how the world is moving towards post-quantum crypto. This slide explains that. So you can see, you can find out the logo for every big guy over here. See, everybody is investing hugely, because within 4 to 5 years, everybody wants the internet to only use post-quantum crypto and nothing else. That is the scenario. Okay. Now a bit of maths. I won't bore you much. But what is a lattice? So if you know, like, okay, let's just talk in form of this example. So R is your real number field, and you are considering a vector space over R. So for that vector space, you have a basis, right? Now lattice is basically nothing but integer linear combination of the basis vectors. That's a lattice. So that's why you can see these dots over here, because they are not continual combinations, they are integer linear combinations. Now we talk about some problems in lattice which are hard. So, oops, I think I missed something. Just a moment. Yeah. So those who didn't follow this mathematical jargon, let's just take an example, very small example. I hope I have time. Yeah. So say I am considering R square. So one basis is this, right? Simple basis set. Now, a lattice is basically defined like this: A0, A1, where A0 and A1 are belongs to Z. Z is my integers. So 2, 3 is a lattice point, but 0.5, 0.1 is not a lattice point. Okay. So now I will talk about one very hard problem in lattice world. So this problem is to find out the shortest non-zero vector in the lattice. Okay. This is called SVP, or shortest vector problem. So you have given a lattice, the basis and all, you have to find out the shortest vector in that lattice, and it's really a hard problem, because you have to find out a very specific integer combination of the vectors. Yeah. Okay. So now it turns out that even the approximate version of this problem is also hard in many situations, which I denote as SVP gamma. So it says that you do not need to find out the shortest vector, but you find out a vector which is at least gamma times the shortest vector, where gamma is not, excuse me. So now all these problems are kind of very hard, because proves that this SVP is an NP hard problem and all. Okay. Yeah.
So you said that not only there needs to be average space hard, but also one direction has to be.
Yeah, yeah. SVP has instances where you can you are not directly use SVP in some sense. You have some variants of that. This SVP is mostly used to prove the hardness. I mean, we actually use LWE or some gap versions of SVP and like that. But there are crypto systems where you can construct a trapdoor based on SVP. So sometimes the trapdoor is not very apparent. You have to construct that in that way. Okay. So that was about SVP. I do not have much time to talk about that. But now this is the problem which we all are very proud about. This is the LWE problem on learning with errors. This is everybody acknowledges that this is the problem in theory. So the problem is very simply stated. You just sample a random matrix from somewhere. There is some space from where you just sample this random matrix. Basically, we do it from some finite ring. And then you also sample your secret. Okay, that is a vector. So this vector is your secret. In cryptography, the secret key, this vector represents the secret. Along with that, you also sample something else. You sample a vector of errors. So we call it errors. So these are also values. The only condition is that these values has to be drawn from a specific distribution, most of the time a normal distribution, and these values has to be small. Okay, it should not be very large, and then you just write down AS plus B, simple linear system you form, right? So let's take an example here. So this is the system what look like. It's a system of linear equations, nothing about that. But the only nice fact is that it's approximately equal to 8, not exactly equal to 8, because you have added some error. Now what's happening here? The error comes from some very specific distribution, normal discrete Gaussian distribution or some bell curve like distribution you can use. And the distribution has certain standard deviation, parameter based things and all, okay. But the guarantee is that you cannot solve this system of equation in the presence of noise. You cannot figure out S by solving this equation. Even if I give you like several equations, if the system is highly overdefined, still you cannot solve. And there is a mathematical proof for that, okay. And if you just try to get the intuition is that because you have some noise over there, so what do? You use some Gaussian elimination, right? So if you are trying to use the Gaussian elimination, the noise also gets combined and all. So basically it amplifies instead of getting reduced. So that's why you cannot solve this system. And I mean, this is the problem that he used these days, okay. Now let's see how to do cryptography using this thing. Very simple. So what was my system? My system was AS plus E equals to B, right? Where S is the secret and E is also some form of secret, but you can ignore that for the time being. Basically, you are doing the cryptography based on the secrecy of S, okay? Now, what do you do while you are trying to make the cryptography from here is something like this. You randomly sample A, it's a public information, just a public information. And Alice, this party, has some S, which is secret information. Now, Bob, who is actually going to compute with the public key, is actually going to encrypt with the public key and send it to Alice. What he will do, he will generate a random bit string, okay? And he also has A, he knows A. Now what Alice will do, he will generate a B transpose, another vector, which is basically S transpose into A plus E. This is exactly the hardness equation that you have solved. Like this is, so basically if somebody says that can you find out S from this equation, you cannot, because it's a lattice problem. So this is the public key of your crypto system, okay. Now what Bob does very simple thing, he just simply multiplies A into X, sends to Alice, and based on B, he also creates something, and this is the bit he wants to send to Alice, okay. Say for the time being, he just wants to send a single bit to Alice, okay. So he just encrypts the bit in this way and sends it to Alice. What Alice does, Alice has this U dash got from Bob. He knows S and he also knows U, which has been sent by Bob. He simply does U dash minus S transpose U, which is approximately equals to bit into Q by 2. So Q is a scaling factor basically. Okay, so let's just see this equation, it's very simple. So if you do U dash minus S transpose U, basically everything cancels out and you are left with this. Now here I told you initially error is small, right? So that's why this factor is very small. Okay. So then if bit is 0, then you are going to get an output close to q by 2. Q is a number, okay, in the integer number. You are going to get output close to q by 2. And if b is 0, you are going to get an output very close to 0. So from there you can easily understand, okay, I have got received bit 0 or bit 1. Okay. So that's simply the crypto system. And now Kyber, okay, is typically based on this simple idea. Okay, there are few things that I completely skipped, like there are terms like module, LW and all. So there are more mathematical structures hidden inside, but everything depends on this very simple looking algorithm. You can form this, use this concept and then form this Kyber algorithm. Yeah, it's a public distribution. It's a distribution, so the only thing is that that exact error string should not be known to the attacker, because if it is known, then he can remove that and do the attack, right? No. Sorry? Yeah, okay, I will explain. So these are the noise parameter, compression parameters and all. So this is something what we are talking about. So there are kind of 3 variants, 512, 768 and 1024, and there are some parameters according to that, the noise and everything, the size of the parameter, secret keys and everything, so they change. But these are just parameters. I mean the mathematics has already been explained, it's pretty simple actually. And people came up with these 3 algorithms. Okay. Now do you think you are secure? You have Kyber, the post-quantum secure algorithm. So what is your point, like, are you really secure? Unfortunately, you are not. That's more like a buzzword, but even real life you are not. Let me show you why you are not. So, this picture abhi baki hai. So far we are talking about the mathematical security, but you have to code it down in some computer, right? You have to write a C or Python or some Verilog code. But when you write it and it is running in some system, whether in your cloud system or in your smart card or anywhere, physics comes in picture, okay. So timing is there, so you can measure the timing of the computation, the adversary, you mean the adversary. You can measure the power consumption of the computation. So say you have a smart card which is running Kyber and you just went to some shop and put the smart card in the payment gateway, right? And you don't know who has put the payment gateway over there. So that payment gateway can measure your power consumption and break your Kyber within few seconds actually. It can do faults. So all these kind of channels we call as side channels or physical channels, and they are the threat to cryptography. So after you develop all the mathematics, you have to take care of these things, and these are big at this point. So almost every week you see this kind of things happening, and you can see like Tesla got hacked by K11 researcher 2 times, okay, and they break their authentication scheme actually, real life. You can see the video, it's in internet. And every company like Intel to AMD, they are scared of this kind of research, because whenever something happens, they have to go and fix their hardware. And whenever they release some new hardware, within 6 months, that hardware is hacked, okay. So that is the current scenario. So when cryptography, you want to run your cryptography in this, what should I say, adversarial world, you have to be very careful. And I won't go in details, but I do this kind of thing. So this is this figure is from one of my paper published last year in CHES. CHES is the biggest conference in our area. So what do we mean by attack? By attack we mean that you can extract the secret key first of all, and the mathematics that you have shown for Kyber, that is actually pretty good actually, that doesn't create any problem. But the problem is basically it's your physics which ruins your nice maths, okay. But when you try to do these attacks are not only like you are just reading out the key from the device, okay. It is basically you are getting some signal from the device which you have to analyze mathematically using the mathematics of Kyber that you have seen so far in a rough sense, and then only you can recover this kind of secret. And the point is that you can do this for everything. I mean, starting from Intel AMD to FPGAs to ASIC chips to small microcontrollers, for everything you can do these things in real life. And if you want to fix this, that's a really big issue, because doing an attack is something, but fixing is something. And what we have seen so far, the fixing, you have to go back to the mathematics. You have to go back to the mathematics. There are something called secret sharing, which is also cryptography. Using those kind of concepts, you can fix this kind of thing, okay, this kind of attack. But yeah, that is a whole, hot area of research kind of, because post-quantum algorithms have just been released, and we are looking into it big time at this point. So this is our lab. Right now we have 2 people, but more people are joining, and we do all this kind of nice stuff. So we have hardware for doing that, so we practically break the algorithms and fix them. Yeah. So that's it, I think, on time, I hope. Yeah. So cryptography is a great thing. We fixed post-quantum, we fixed the world even before the quantum computers really arrived. But then unless you take proper care in implementation, it's really futile, okay? And implementation does not mean that you code well, you code correctly or not. It's basically more to that. So you have to, do some kind of mathematics and then implement that mathematics also properly. So whole lot of exciting things running over there. So with that, I would like to just acknowledge that some of the slides were taken from our previous teacher's presentation, and very nice talks on post-quantum cryptography by some, stalwarts in this area. And with that, I would like to conclude. Thank you.
Thank you, Professor. I request Professor Sujoy to give away the token of appreciation.
Okay. Oh, thank you.
Sorry, did any of you have any questions for Professor? Any questions?
Hello, sir.
Hi.
Sir, actually, normal computer can't decrypt the RSA algorithm, but for the quantum computers can do that. But we don't know actually that when it powerful quantum computer can become. So how we ensure that our algorithm that is working encrypting, make sure we are in secure mode.
So the question is, are you talking about the mathematical security, like with respect to the quantum computers, or you are talking about the physical security, just which one?
Mathematical way.
Mathematically, it's known that it's secure. Like if you are running it on, if you are encrypting right now with RSA and you don't have a quantum computers, you are good.
But the companies like IBM is developing and working on that, and they are not publishing that when it so much powerful computer that release.
Everybody is working on quantum computers, and like these things will happen anytime. And right now I can say, like if you talk about IBM Condor and all, these computers are pretty powerful. And another point, like we are still relying on Shor's algorithm. Okay, Shor has given some algorithm, we're relying on that. Some people I know, they are working also on improving that perspective. So it might happen that the, people will come up with some better version of Shor's algorithm which breaks quantum cryptography in lesser number of qubits. We do not know that yet. So we do not know many things actually, but we cannot take the risk. That is the main point.
But there may be some vulnerabilities in the code itself, like developers are doing encryption algorithm. So how
there
to
is no
ensure?
vulnerability in code. We are not assuming any vulnerability in code. Code is perfect, that we are saying. So if you are talking about this physical security, that we don't assume that the code is vulnerable or anything. Everything is perfect, but still the physics actually leaks some information here and there, and from there and doing some mathematical cryptanalysis, you can recover whatever you want. So that is the assumption. Yeah.
Sir, in RIGEP's public key crypto system, RIGEP's, RIGEP's, sir, the latest based public key crypto system.
I have not heard about that. I'm not aware about that. But
sir, in your slide page number 25, it was.
Okay. So it's on my slides probably. This one? Oh, Regab, Regab. Oh,
yeah,
okay,
Regab,
okay.
yeah, sorry.
Yeah.
So how do we decide the bit should be 1 if the value is close to q by 2?
Oh
Like,
yeah, so
how close?
basically,
Yes.
how close is basically like I showed you, right, in the next slide here. So it's E transpose x plus bit into q by 2. So let's say the bit is 1. Okay, let's assume the bit is 1. So this value will be q by 2 plus some error, right, plus some error, and that error is basically a small range. Okay, so what you do basically, you do some kind of quantization there. So if the error is very big, you cannot recover the secret. But since it's like, you can imagine it like this, you have a wheel and then you draw some spokes, right? So in between one spoke, your error can be there, okay, but if you take the average of that or something like that, that is your actual value. So you can, so another way of looking into this is that this will be stored in some register when you are decrypting it, some 32-bit register or 64-bit register. You can simply drop the last few bits from the register, that will be the error. And after that, whatever you get, that is probably equals to q by 2 or something, and that is your secret.
Yes, sir, one more. I want to know from you that how the source algorithm is able to like crack this public key system that is based on integer factorization and discrete log.
Okay, so you are asking that how Shor's algorithm works?
Yes.
Okay, so
And
that's a very
sir,
good question.
Yeah, one more.
Huh.
And why increasing the size of the key is not sufficient for the
yeah.
traditional?
Coming to that, so I don't have a slide for that, so I will just go take verbal. So there is something called Euler's, Euler's theorem, which says that if you have a number g, okay, so okay, you want to factorize n, right? So do I have a pen over here or something? It's really hard to explain in words. Ah, yeah. Oh. Oops. Hope it works. It barely works, but I hope it will be fine. Oh, here are some more. Anyway, so let's say I have, it's fine. Can somebody grab a pen? Yeah, I think we can take it offline. I will take it offline, you can talk to me after this talk, with a pen and paper.
Sir, I'm still confused that point number 2. Like if the value is close to q by 2, then we decide the bit is 1, but otherwise it's 0. But what is the condition for otherwise? Like how close?
Otherwise means it will be, see, if the bit is 0, what will happen to this multiplication? It will be 0, right?
Yeah, only
so
the
it will be E transpose x. So I said E is a very small value.
Okay.
So E transpose x will be a small value. Okay. You are multiplying a small value with some small value, it will be small value only. So then it will be something close to 0, say 0 point something.
Okay.
And there it will be close to q by 2. So say q by q, say let's say q is 10, okay? So it will be close to 5, like that. So if it is close to 5 or close to 0, you can easily distinguish, isn't it? You also have the same question? No, I think comma is the... Huh? So there is no 0 in the other one. Oh, achha, that's it. Okay, it's yeah, sorry. Anything else? Anybody?
Since companies are building the quantum computers, are they also working on developing algorithms that will make our data secure? For example, because quantum computers are not only for breaking the security, right? Their usage is varied. So, like if the companies like IBM and all those, if they are working on building those computers, so is it legal for them to build such computers that will endanger the security of the almost the whole world?
Okay, so you are right that quantum computers might have many applications, but right now we do not know much applications of that. So in terms of legality, so there is one point, it's science. So you should not always think about what is legal and what is not. You are not going to attack somebody. just doing mathematics and physics, it's good, right? So it was also not legal to make an atom bomb in that case, but we made it. It's like that. And secondly, yeah, I mean, quantum computers are being researched. At the same time, we are also building this post-quantum crypto, right? And we have standardized it. We are going to replace everything by that. So in research, whenever such a threat looms, we try to find out a fix. So that's how research progresses, and that's what is happening right now.
Does this also increase like the number of people who might be needed in the workforce related to computer security and data security?
Yeah, definitely. We are badly lacking people who, wants to jump into mathematics or wants to jump into this kind of physical security field. We need a lot of people in that at this part. Otherwise, there is always some kind of vulnerability looming around. It is just you who can figure it out, and once you figure it out, then it's public. So it is there. Somebody has to figure it out. So more people we make it involved, we make our world a better place in that sense.
Okay, thank you.
Thank you. I think that's it. Oh yeah.
Hello, yes. So sir, how does this compare with relatively trivial algorithms, key distribution algorithms such as BB84? So we could have the classical implementation of sharing the same bits but via quantum channels.
So I'm not very much aware about the quantum information processing and all. Sorry about that. But yeah, I mean, this is a different subject altogether. I'm not talking about quantum key distribution and all these things here. It's more about the cryptography.
All right.
So comparison, these are two, like apple and watermelon, actually, I would say, in that sense. Yes.
Public key cryptography like RSA and all are used in very critical applications like banking, finance, and so what do you think that by what timeline these institutions must migrate to the post-quantum cryptography?
Right now, and they are doing it. Like for example, I'm not sure about banks, but I know, like if you take the example of Apple, NVIDIA has recently brought a post-quantum secure library for doing post-quantum crypto on GPUs, and then if you see Apple, they have already included PQC in their E2E. There is something called Apple Talk or something, right? There's an app, I mean, like WhatsApp in Apple. So they have already included K-bar in that.
Okay, so are there any such guidelines from the regulators or the law enforcement agencies that post-quantum cryptography should be implemented by which date?
So when NIST standardized it, it is kind of implied. So NIST is not going to say you that you have to do it, otherwise I will put you in jail. But it has been done, so people are now migrating quite massively.
But in India, anybody has some imposed this thing that yes, by this timeline?
India started this NQM, right? National Quantum Mission or something. Okay. So under its government. So they have started already doing that thing, and like few of us are already working in this area. So researchers are there, and I had talks to some government body, DSCI people and all, and everybody is basically moving towards that. So in fact, there was some talk, I remember, people were saying that should we also run our own PQC competition, like Korea is doing that already, Korea, China, everybody is doing that. But yeah, still in ground level, but we are aware, at least. People have started working, I guess.
Okay, thank you.
Hello, sir. Recently, North Korean hacking group called Lazarus hacked Bybit's cold wallets, and they don't even use the supercomputers. They use some other method. So and it was a multi-million-dollar attack. It was like $1.13 billion attack. So groups like North Korean groups and Russian groups are not even using supercomputers, and still these massive scale attacks are executing in the world. So what do you say about that?
You see the slide? This is the thing. Like all of these are billion-dollar business. So probably North Korea, they haven't told you how they do it. But But the thing is, I suspect what I say from there, they must have done some kind of this kind of hack.
But sir, cold wallets are like one of the hardest wallets to hack because they are offline. But still, they got hacked.
See, I mean, this hardness thing, I mean, it's not cryptographic hardness we are talking about, that hardest wallet to break and all. These are kind of, unless you try it, you don't know how hard is that. Everybody will tell you before selling it that I have the best security in the world. Okay.
Yes, sir.
But then, like, if you see these attacks, especially which are happening on this Elon Musk Starlink system, or I don't take his name for the time being, or
Yes.
Tesla tests their car like anything, okay, and still send it to some university, some students will hack it. So it's
Okay.
all about, it's a cat and mouse game. So if you think that, okay, how they have breaked in and all, there are intelligent people who broke it. That's it.
Okay. Thank you, sir.
Okay, I think it's done. Okay, great.
Thank you, Professor Shaindeep.
Thank you.
So now we have our panel discussion. So I request the volunteers to just request volunteers to help with the arrangement, please. So we'll be starting the panel discussion soon. Couple of minutes.
Okay, just very overview like talk, not much technical. Hey, it was okay.
It was very nice. Thank you. Can you share your slide with
Yeah,
me?
sure,
And just like some points and
अभी कर देते हैं. It's very high level, but I have an extended slide actually. Yeah, sure. Huh?
best way, yeah, it was very
Okay, thank you.
You should give us three.
Come on. Oh my God, I just. Sorry.
Hello, hello, hello. hello.
मैं समझा नहीं क्या क्या, क्या बोल रहे थे शायद.
As an alumnus of IIT Bombay, who did BTech from Computer Science Department, Aman co-founded Cogno AI during his final year, which was acquired by Exotel in 2021. I request Aman to be on the stage. Okay, thank you. Secondly, I call upon Dr. Vineet Nair, co-founder of Arithmetic Labs. Dr. Vineet Nair is a co-founder and chief scientist at Arithmetic Labs, an R&D studio built building high-performance crypto systems. His team works on designing and building cryptographic proof systems. He earned his PhD from the Indian Institute of Science and was a postdoctoral researcher at Google Research India. I welcome Dr. Vineet Nair. Thirdly, we have Dr. Vrinda Dave, architectural formal verification engineer at Intel. Dr. Vrinda Dave received her PhD from CSE Department IIT Bombay under the guidance of Professor Krishna for her thesis on some fundamental problems and applications of word transformation. She received an honorable mention of ACM India Doctoral Dissertation Award 2022 and an Excellence for PhD Research Award from CSE Department IIT Bombay. She was also a finalist for the E.W. Beth Outstanding Dissertation Prize 2022. She works as an architectural formal verification engineer at Intel.
Next we have Dr. Priyanka Nayak. Dr. Priyanka is a research scientist at IBM India Research Lab and is part of the GenAI platform team. Priyanka's prior research explored the space of cloud deployment, networking, and observability of microservices such as network functions and extended the same for multi-cloud deployments. Before joining IBM, she received her PhD from IIT Bombay, India. She is a co-author of a cloud networking book and has also recently been appointed as an ACM eminent speaker. Up next, we have Dr. Nagarajan Natarajan, researcher, MSR India. He completed his PhD at the University of Texas at Austin under the guidance of Professor Inderjeet Dhillon. At MSR India, he has worked on a broad slate of machine learning problems at the intersection of AI and software engineering, AI and systems, as well as in learning theory and optimization. His current interests are largely shaped by the big challenges we face today as we increasingly deploy black box large language models in real systems like copilots. Up next, we have Professor Shivram Kalyanakrishnan from our own Department of Computer Science, IIT Bombay. Professor Shivram is an associate professor here. He specializes in artificial intelligence, in his own words, driven by the goal of creating intelligent agents, especially ones that can learn. He considers questions in sequential decision-making, multi-agent learning, multi-armed bandits, and humanoid robotics. Application domains include robot soccer, computer games, and online advertising. This panel will be moderated by Professor Varsha Apte, HOD, CSE IIT Bombay.
Thank you. I think given that I'm vertically challenged, I feel like I should just stand most of this panel because I want people to see the faces and so on. So maybe I will just be standing. And it's all pretty informal, folks. This is not like a big, some PR event run by some commercial company or something. It's just us, the students, us, and many of them being our alumni. If they're not alumni, they certainly are our well-wishers and friends. Okay, so it's all a bit informal. The name of the panel is not here. The topic was shaping tomorrow's workforce. Okay, before we go into the actual discussions, I just want to tell you a little bit about the logistics of the panel. First thing, I'm going to request the panelists to be brief because we have a lot of questions. I've already told them that, but it's okay. Please do finish your thoughts and please do say important things. The other thing is, although we got a lot of questions here, the idea is not that I will read each and every question from here. So I want to give a minute maybe to those who already asked questions and would like that question to be picked and answered and so on. You should ask it yourself. And the best way to do that, the mic distance will reduce if you come in the front now. So in the first couple of rows here, for example, there are a lot of spaces. If anybody already knows they want to ask a question to the panelists, I'll just wait 30 seconds. Maybe people can just come to the front. Of course, some questions will come impromptu, that's fine. But if you knew you had posted a question here, you want to make sure it gets asked, you want to be the one asking it, please come in the front here. There'll be a little bit optimization later. And by the same token, since we have only a few people coming here, a lot of impromptu questions will come. I really request the mic volunteers to be very agile. Please face the audience. Please spot the people who are raising their hands. Quickly run to them. Don't hurt yourself, but try to sprint to them as fast as possible. And the people who want to ask questions, please raise your hand while the other question is being answered. Okay, so we can have some efficiency, otherwise too much time will go in mic transit time. Okay, so with that, without further ado, actually I wanted to ask a question that is not here. Many of these questions are a little specific. I thought I will ask, also every question I will probably not ask each panelist, so I hope that is okay with you. I want to ask the first question to one of each type of people we have here. We have two from startups, two from industry R&D, and we have actually only one there from the faculty, so that's enough. I will probably not answer any question. So I want to ask the first question to just as a warm-up that let's say maybe Aman, you, because you're here right next to me, and maybe Vrinda, and then Shivram, as to if you could shape tomorrow's workforce, you had some magic wand by which you could shape the workforce exactly to the way you want. What would that shape be? Aman.
Hello, am I audible? Yeah, so I think in computer science department and generally people from engineering domain that I've seen, people are generally very good at very vertical thinking, right? So this is coming, by the way, from a startup founder. I'm not a part of a large corporate. So all I'm saying, I've seen people who are very good at one thing and they are able to do it very deeply. This is extremely useful in large corporates. So let's say if I'm joining Google and I'm great at building search engine related algorithms, so that, it makes me a perfect fit candidate for a large company like Google. So when ma'am asks what according to you, would do to get an ideal workforce. So first of all, for me, for a startup founder, an ideal workforce will be someone who can think a little more horizontally rather than just going deep, right? And that requires a lot of second order thinking, which means if I do this, what impact will it have on other processes? Simple example, right? We have a small team, right? I started my new company 1.5 years back, so about 20-25 people in the team. Engineering team makes a small change in the product. Maybe it requires some extra parameter while logging into our product, right? Very simple example. Sales people are not aware of it, and in front of client demos, they are goofing up. It happens all the time, right? Sales and engineering teams fighting with each other. So now the engineer who is developing that feature, he did a great job building and engineering, making the product maybe more secure. Let's say they developed that feature for additional security, but they forgot the second order impact that ultimately this is impacting my sales team. They need to be coached that this new feature has been added, and please be mindful of this feature when you are showing it to the client. Otherwise, your usual sales demo pitch will break. This is a simple example. So for me, an ideal workforce would be someone who can think a little more horizontally rather than just vertically. So T-shaped learning curve where you are good at a lot of things, but extremely good at one thing. That's the kind of ideal workforce I can envisage would work very well at startups.
Thank you. Vrinda?
Yeah, I think I agree with Aman. That's, I think, better answer than what I thought. And I also agree, like I have seen, even in large companies also, that is somewhere the issue is there, that some people, even management people should also know about tech a bit so that they can manage well. So, yeah, I agree with Aman what he said.
Shivram?
Yeah, so I think I need a slightly more powerful magic wand than Vrinda and Aman, because here's what I would like, right? I would like youngsters to work on the most important problems that the world is facing today, many of which are not in companies' interests to solve, many of which are being, if anything, prolonged, right, on account of more myopic short-term thinking. Your future, more than mine, depends on global warming, right? The rate at which our world is warming up. I'd like most students to look at something like that. Even if we stick, I guess, in the context of computing and AI, the world is not all about LLMs, right? As we are sort of made to think today. There is so much more about human beings, how they interact with AI, about how much heat AI is producing. There are many problems, I think, which are very important for, our future, which are not currently in the crosshairs of industry, right? It's not what shareholders are interested in. I'd like to wave my wand and make all of you work on those things.
So I'll ask one more question and then we'll just open it up. Maybe Priyanka, what are the key differences in doing research in academia versus industry, and how should one decide between the two? So you can give, you've done PhD in academia and work in industry.
Yeah, so it's a very good question, and it's something that always comes in anyone's mind. So academia is something that's very open-ended, and it gives you a lot of flexibility on what problem you want to solve. As Sir said, that you can work on global warming that industries are not currently working on that way, right? But there is one aspect of things that academia gives you. But in the industry, you work with the problems that your clients are facing, or you can do a direct impact through your research as well, right? You can see your research being in a product that's working, that's being used by a lot of users. So I think it gives you a sense of satisfaction as well when you see your research or your work going into some product. So there are pros and cons of both, but I feel there are different things that excite you that way. So the openness in academia versus the application of what industry provides is the key differentiator.
Thank you. Nagarajan, if you want to also add to that, and I also had a follow-up actually which is very related, which maybe Vineet can answer, that what is the role of startups in driving research and innovation today, and how do they differ from academia and industry? So Nagarajan first and then Vineet.
So I'll answer the question that was, yeah. So before I start, I'll also make a point, a response to the point that Priyanka made about academia today can actually work on anything they want. If they want to work on global warming, they can't. But unfortunately, the politics also dictates what you want to work. So given the recent political climate, I don't know if you can work on global warming. So that bit aside, there are long-term problems in both academia and industry. For example, Microsoft had this recent breakthrough in quantum computing. So, and I recently learned that Microsoft has been funding that team for 17 years. So Microsoft Research took that sort of long-term vision, which is fairly long-term. In fact, it was not even clear that this research is going to pay off. We have some breakthrough now, and we don't know how long this will sustain, and if this breakthrough is actually real, that we'll actually have something tangible in the coming decade. But we'll continue to support that kind of research, because if you think of companies betting on these research agendas, they will want to put some non-trivial amount of chips on projects that have very high impact if they succeed, right? So companies will always want to take such bets, whereas academia can do a little bit more relaxed in these kinds of betting. They can put somewhat more evenly, whereas academia cannot, industry cannot afford to put these bets evenly, but they will still have to make bets on these improbable success events. But if they succeed, it'll be very huge. Yeah, thanks.
Thanks. We need the role of startups, and please start asking for mic now. After this, it's going to go to students. Mic people, please be visible for the audience. Yes, we need first.
Can you repeat the question?
So the question, this is again from some students. What is the role of startups in driving research and innovation today?
Okay. So firstly, thank you for inviting me here. Very happy to be here. So what I realized when we started this company, and I've been part of this for like now two and a half roughly years, is that the process actually doesn't change. It's the fundamentals that change. So here also we ask questions. So like in research, we ask questions. We have some broad set of problems that we are interested in. So here also we ask questions. What are the problems that could actually have impact? The real difference is that this needs to have an economic impact. And now you really go and think, what would you require to actually build this product out? Would you require a lot of research? Would you require a lot of engineering? What is the trade-off? Can you get the product out very quickly? Can you not? And then it's short-term game versus long-term game. And then there is a real amount of effort on distribution. So the research aspect comes very late. It is actually about the question and what kind of impact can this question have? If you solve this problem, what is the economic impact? How can you sort of be profitable as well as help the community? So this is essentially the difference. In research, you are sort of happy if your question is interesting to your research community, to your academic bubble. Like, so if you are sort of happy with, if your community is sort of happy with the question is interesting, you will sort of go and solve it and then share the solution, and your paper might be peer reviewed, accepted. But here, the factors are different. Fundamentally, the process is the same actually.
Okay, thanks, Vinit. Okay, anybody has the mic, wants to ask a question?
Hello. Yeah. So my question is like sir mentioned about the problems like global warming and all those important issues. So up till now it was a choice to work on those problems or not. But with certain government regulations and all those laws, it's now important for industries to go on this with heavy hand and make more efficient machines or reduce emissions. But still now there is no such stringent regulations on academia. So still it's like ma'am said, it's free flowing and you can work on any issues I want. So I want to understand, like, is there an option or would it be a good idea to bring that rigidity into the academic research on working such problems, or maybe making sure that some part of that research goes into like that aspect?
Shivram, you want to take this? I mean, I also have an answer, but Shivram.
Actually, if you have an answer, I'd rather that you took it.
No, my answer is that at least academia in India, and I imagine everywhere, we are already super constrained. So if you look at our carbon footprint, it would be very low compared to the Microsofts and Googles of the world anyway. We don't need an additional artificial regulatory constraint. We are already really, we need one more GPU, and we are please talk to the PhD students here who are trying to learn their LLM models and fine tune them and so on. We don't have 30% utilization and 20% utilization and things like that of our data centers. We are super optimally provisioned. It's not a problem we need to solve, at least for Indian academia, and my guess is not even for any academia anywhere in the world. On that said, it will be nice. I have actually worn the hat of infrastructure in charge here in IIT Bombay. We have a data center and so on. It would have been good if we could have applied some of our, at that time in my research, I was actually working on power performance trade-offs, and I was actually trying to connect it. There, then we run into the same problems as, practical people do, that this is an infrastructure that needs to run, and we cannot really apply our optimization research and so on to that infrastructure. I wish that we had the hands and the systems in place to do that synergy right on the campus, much better than we do. I'm hoping it will happen like that in the future. That's my answer.
I'll add a small point. I'm not from the research background, but if I were to choose research as a career option, I would not want constraints. There should be a choice for someone. So as someone mentioned, right, in corporates, industry research, you have constraints because you have to optimize for profit. But let's say someone doesn't like that, and then they take an alternative career choice of going to research. And then ultimately you end up with more constraints in your academic field. Then there is no point of getting it. There should be a career option where there is no constraint and I can do whatever I want.
That's academia.
I mean, just to give you some examples, in college, some of you can empathize, right? I was very sad when I graduated from IITB because the college life ended and all that, but I was very happy about one thing. In every semester, there used to be one course of not from computer science department, which was enforced upon us. I don't want to take names. I'm sure all of you know, all of you have those courses. And I absolutely hated them from the core of my heart. So that was the worst part of my 4 years at IITB, and I totally don't see why they should go on for MTechs and PhDs. And as you grow in life, your career options, your choices should open up and it should not be constrained. When you are young, it makes sense to put more constraint because you don't know the syllabus of your life. But like, think of it, if I'm starting a business, And I'm told, no, you cannot start a business in software, you have to do only automobile engineering. That's not the right thing, right? As I'm growing up, my choices should open up. So for PhDs, it absolutely makes no sense to put constraints.
Okay, next question. Please raise your hand in advance. We're wasting time moving mics here and there. Somebody, there is another mic there, right? You have a mic? Yeah, so over there, if somebody has a question in mind, raise your hand, keep the mic.
Hello. Hello, sir. My question was to Shivram, sir. So recently, there's controversy where DeepSeek launched a model R1, and it was costed around $6 million, and whole Nasdaq and whole Silicon Valley goes down, and Nvidia goes down 17%. And people said, like, if we can train a model 673 billion parameters at 6 million cost, and GPT-4 costed around $100 million to train. But I think training a model from scratch like GPT-4 did is a hard, and reproducibility is like comparatively easier. So what do you think about that? Like, because GPT-4 created that model, like OpenAI created that model from scratch.
So what is the question?
So like question was, like, the whole Silicon Valley and whole NASA went down because they thought that a model can be trained with $6 million, but it was they reproduced that model because OpenAI already did that. So what do you think? Like, is it a fair argument that a model can be trained in $6 million?
Frankly, I don't work on LLM technology, so I don't really know the technical feasibility of whether you can reproduce. Nagaraj is probably like better equipped, so let me hand him the mic.
Yeah. So, by the way, the verdict is still out, I think, on that debate. What the actual cost they spent is, mainly because I think the costs don't take into account the actual training time that went into building the DeepSeek V3 base, which is an 800 billion parameter model, right? So someone has to have trained that model to be very good, so that you can then do whatever they did to get to R1. So there are lots of hidden costs involved, and we don't know what the true costs are, what the actual hardware that supported the training is, and where they got the data from. So there are lots of open questions, and anyway, it doesn't matter to us. What matters to us is that they actually put the code out, like put the technique out, and that's all matters. And the best thing about all this fiasco is that something has been shared with academia for reproducing things, and there's been a flurry of work since R1. And lots of healthy debate, and I think that's all we should take from all these things. Yeah.
I have one more question.
Can we move on to something else? Follow-ups we'll take later. So I wanted to bring back some diversity to the questions, also bringing it back to the shaping the workforce thing. There was a question here, I'm not sure, the NVIDIA question, who asked? Are you here? Otherwise I'll read out your question. So it says here, and this is to Vrunda. The NVIDIA CEO recently mentioned that they have AI working 24/7 to design new models and chips for them. With AI-driven automation playing such a critical role in hardware innovation, how is Intel leveraging AI for chip design and optimization? Do you see AI fully automating semiconductor design in the future, or will human expertise always be essential?
The basic thing I would like to say that nobody knows the future. So yeah, it is doing things, but it still will take some time. It's not up to mark. It has many things to do yet. For example, in my work, I do not see right now it is working. Like, I work in proofs, so getting proofs. And I've seen like AI is not giving full proofs for many simple things. Another thing, Intel is working on it. Yeah, it is catching up with other companies. More details, I think I'm not able to say that about it.
Okay. Anybody else wants to add to this, especially from the semiconductor?
I can't answer specific to the Intel company, but in general, if you ask this question, because this is a huge debate actually, like would AI replace normal workforces? But this question has existed throughout the 20th century. So if you look at 1930s, if you look at 1960s, if you look at early 2000s, these questions have always existed, whether the new upcoming technology would replace the existing labor force. This is like a question that has come and been persistent throughout. And if you see the data, it's yes, the current labor would get replaced, but always new labor is formed. So the new AI would definitely, like the tools that AI is going to help build would generate new kinds of labor. So the definition of labor would change. Now the real question that you need to worry about is whether the existing labor that is going to go away is going to be very quickly be replaced with the new upcoming labor, or it would take a lot of time for the new labor to come, and that means a whole bunch of people who are actually doing what they are doing right now would be replaced and they would have no jobs. And that is a real concern. So essentially for tomorrow's workforce, what is more important is that you learn transferable skills. So you learn skills that you can transfer to the next wave of technology or next set of skills that you might have to learn as to what is important. That's what I.
So we can keep that theme. There was another question here I actually really liked. Again, I hope the person would have been here raising their hands. The last part of the question, the first was what we have already talked about a little bit. How are LLMs and AI tools changing the landscape of work and research, particularly in software and coding? And I think Nagarajan, you might have something to say about that. Aman, maybe you too. But the last sort of piece of this question was, what's the future of work? So, very nice broad question. Aman, maybe you could.
So I'll give an example in our industry, right? So my company, for example, we build speech analytics solution for banks and financial institutions. So when you call a bank, you hear that this call will be recorded for training and quality purposes, right? You would have all heard of it. Behind the scenes, what happens? Any guesses? Anyone? So there is a human auditor who takes a random sample of call. So one telecaller typically does 50 calls a day. In a month, they do roughly 1,000 to 1,200 calls. And an auditor behind the scene picks up 3 or 4 calls per telecaller per month. And they have a quality sheet to fill. For example, they will listen to the call and say, did the agent greet the customer? Did they authenticate the customer before sharing any information? Did they ask the customer for feedback at the end of the call? Right? All those things which you do in a typical customer support call or a whatever. You call your Indigo Airlines or anyone. So these human auditors are actually doing this job of filling the quality sheet. Now, it's fairly straightforward to automate it to a large extent, because what we did was you transcribe this call, take the call recording, convert it into text. On that text, you can run a language model. It's fairly straightforward to do prompt engineering and say, did the agent greet the customer at the beginning of the call, and write a detailed prompt that this is the meaning of greeting, right? I'm sure everybody who understands LLM can correlate. It's not rocket science. End result is that some of our customers are starting to repurpose their auditors. Repurpose as in moving them to different teams, which is essentially a better way to say laying off their auditors, right? So, of course, these auditors will have to find other jobs. Sooner or later, we are starting with the auditors. We will come behind the call center agent as well, right? With voice bots and voice AI agents coming in. So, as Vineet mentioned, what will happen is historically, I don't know if some of you know, before alarm bell came in, I read somewhere that there used to be a job where people had, people will wake up others at 5 a.m. You can hire someone and say, wake me up tomorrow at 5 a.m. because I have to take a train. So they will knock your door at 5 a.m. in the morning. Alarm bells came in. These people lost their jobs, of course, right? Physical newspapers, I'm sure all of us have grown up with newspapers being delivered to our houses, especially those, born in late 90s or mid 90s. But now my parents, for example, they have an iPad and they read Amar Ujala digital newspaper, Dainik Jagran, Amar Ujala and all that. So these kind of things happen. But as Vineet mentioned, it's a question of how fast the technology is being adopted. If that happens across 10-year period, then these people who lost their jobs, who saw their jobs going away, they have a 10-year period to find another job. And 10 years is a long enough time frame for people to find alternate jobs. But imagine that happening in 1 or 2 years. For someone who is, let's say, not so educated, not so tech savvy, these auditors, they are not very educated, not very tech savvy. For them, of course, it's not so straightforward to pick up a skill and then become skilled in that tomorrow. If this would have happened gradually, it would have made sense. But, ChatGPT was released, I think, November 2022, if I'm not wrong, right? So 2.5 years, technology today in India is here. Cloud, for example, has taken a lot of time for adoption. Even today, people use Tally on their laptops. The Tally is not on cloud, right? Tally on cloud and all is very rare. So all I'm trying to say that this technology will take away jobs. I mean, some of you might say, Aman, why are you doing this? If I don't do this, someone else will do it. Banks have this problem statement. They will ultimately get it done with someone else. So I'm not the culprit. Ultimately, technology is the culprit. But point I'm trying to make, AI will take away jobs. People will have to update their skills at the pace of AI, otherwise they will be jobless for a certain time frame. But ultimately they will find jobs. Maybe they will be jobless for 3 years, 4 years, 1 year, 6 months, whatever. But then they will have to find other jobs.
Do you want to add something?
Yeah, so I want to take this question from the software engineering coding point of view, and I like two parts that Aman mentioned in his answer. One is this question debate has always existed, and the second part was that what is more important is transferable skills, right? And both these answers also ring true in the software engineering and coding domain. If you think about it, there has always been the quest for the ideal programming language, right? So C used to be the programming language, and we were tested on C, and interviews were on C, and so on. And then Java came about, made a big deal about memory handling and so on, and then Python came, and now pretty much everyone has shifted to Python. And of course, so people, but what enabled people to move from C to Java to Python is because the basics of all these languages are the same, right? Understand the notion of variables, data, control, and so on and so forth are the same. So if you pick it up in one, you'll be able to apply in the other. And just it makes our life easier when you go from C to Python. And the same is happening, just that we are going from Python to natural language, right? We are sort of starting back, going back to where things start in our minds, which is usually the language that you learn things on. And even here, developers will start to use these tools, right? People will embrace these tools. Just like today, when you write code in Python, you don't understand, not everyone is going to understand what is going behind the interpreter of the Python, right? You don't need to understand the inner workings of the interpreter, yet you can write a very good piece of Python code if you understand the basics. The same thing will happen in the future programming world as well. These tools that AI is going to help developers write better programs with natural language, they are going to be there to assist them. So even if you don't fully understand the AI behind it, you will still be able to produce very good code as long as you understand the interface and you're able to do this application of knowledge, like this transfer of knowledge. Yeah.
Thanks. Any questions from the audience?
Ma'am, my question is to Natarajan sir. I have very
Can you
limited.
raise your hand? Okay.
I have some experience with LLM agents, sir. It seems to me that it's very difficult to debug them. Even small changes manifest as unpredictable outcomes, and they're extremely computationally expensive to run. So how is the industry solving these kind of problems?
Yes, this is a question that requires a lot of discussion, debate, and so on. By the way, that's not a problem, that's by design, right? I mean, LLMs are statistical machines, so they're supposed to behave like how they're behaving. And it's our job to build the scaffolding, all the guardrails that you want to build around it. Agents part, yeah, I mean, you can call it agent. I can just call it a model. At the end of the day, it boils down to the stochasticity of the model that's behind these agents. And the reason they are doing so well is because of the stochasticity, right? If they were deterministic, they wouldn't be as well as they are today. So we have to think about how to build these guardrails and scaffolding around these agents, so that we can succeed in the applications that we are actually putting them into. Yeah.
So actually, I'll segue to maybe Priyanka here, because your question was about efficiency and using a lot of resources or something like that, right? So can you give a systems view on this? And I will just go ahead and ask one follow-up also. Okay, maybe answer his question then.
Yeah, so as ma'am said, right, LLM agents, you said it's not resource heavy, and a lot of things, in fact, I'll go to Shivram sir, that there are a lot of things that global warming thing or any things, they require a lot of compute, right? And GPUs are scarce. Even if industries have a lot of GPUs, getting them in the industry is also a challenge, because there are a lot of people, everyone needs them, right? So you're doing them, scheduling them efficiently on these GPUs is what is something that's an open problem, that's open research problem that system folks like us are solving that way, right? So there is a problem there, and we need researchers and engineers like us to solve that problem. Yeah.
So keep the mic, then I have a follow-up for you. We have a lot of second year, third year students, fourth year, maybe masters, first year also. So if some of those, if operating systems and networks or compilers or something like that, OS and networks you can answer maybe. If that's their favorite subject right now, but they are dreaming about being in either IBM research or somewhere, what is your advice to them?
Yeah, there is. I mean, I'll tell you, everyone feels LLM is the thing. You have to be a data scientist or you have to know LLMs to work in industry. It's not the case. I understand that's the top layer that everyone thinks. These are the applications that are being deployed or that are being widely used now. But underlining to run these, you need your systems knowledge, your system skills, right? You need these to be running efficiently on your GPUs. You need them. You hit, like if you run your LLM model, you'll hit out of memory, right? What you do, you have to solve it going at the lower layers and solving them what needs to be done efficiently at the layer below, right? So we are scarce resource, if I'll say, but we are kind of required for smooth running of any system that's there running LLM models in the industry or in the world now.
Yeah, thanks. Okay, back to students. Yeah. Okay, yes, go ahead. Whoever has the mic.
Hello. So I think everyone can answer this question. My question was that how can companies create programs or initiatives to identify and nurture R&D talent at the BTech level? Because like we can see that the big companies, they mostly hire R&D people from masters or PhD programs, and somewhere it feels like the BTech level, while they move to masters and all, they kind of lose the motivation. That is what I've seen with my friends and all. So I think that there's a need where companies need to nurture this talent at BTech level as well. So what are your views on that?
So the three big company people, maybe you can answer.
Yeah, I agree with you on that, but what companies are doing, in fact, IBM Research is doing, we run winter schools and summer schools in collaboration with universities so that we give opportunity for talent to learn things that are needed for the industry that we are doing on day-to-day basis, right? So you can join these winter schools that ACM hosts with us and be part of these, learn these skills, right? Apart from that, what we support for BTech students to do is join our internship program, right? We have our internship programs every year. Our openings come out around August, September. I think most companies have that. You can join that, and there are no restrictions on if you should be a BTech or you should be a master's. We look for skills that can be applied and that can work with us and our problems. So that is another opportunity for you to come and work with us or come work in a collaboration.
Yeah, so I'll just go back to your first question. So, and Aman's answer. So, and I also have a vision on that. So, the most important thing, according to me, for like the next generation is to become the builder nation. Like, you really need to start thinking about how you can build products, and that requires people to not think vertically. You need depth, but you also need breadth. So if you understand what the building pipeline is, then it becomes easier for you to start coming into industry and contribute very quickly. So what we try to do is, like in what we do, it's very hard for somebody to come in and just start like immediately. So when they come in, we have to sort of introduce them to the building process and understand what it means to build systems at scale. So for people who are in their second and third years, when you're doing your courses, you should really try to understand what is the building activity, what you're learning, how it came about, why is it that you are being taught this, and what is the building activity that led to these courses that you're studying today. That is the building process that you need to understand so that you can come in and apply these skills across verticals, and that is important. So that's how I think. And probably offering courses from industry people who sort of can give you an idea how you can build things across verticals. That's how sort of you can help do this.
I'll add something. So, see, a parallel example, why do top companies come to IIT Bombay or Delhi or IIT Kanpur or maybe top colleges rather than going to every college in India, right? The simple reason is that probability of finding someone whose chances of succeeding are high is more at top colleges compared to going to other unknown names, right? It's that simple. It's pretty much the same. I think companies invest in PhDs and masters from a research point of view because the probability of finding an alignment there is much higher. At BTech level, honestly, in my BTech days, I did an internship in Germany, TU Braunschweig, right? It's pretty, I'm sure it's known there. TU Braunschweig comes and hires interns. So I could not contribute much because I was still figuring out my career. Someone who has gone to masters or someone who has opted for a PhD, at least they have taken a career choice that they want to go for PhD. At BTech level, it's still a discovery happening. So now coming back, companies like IBM, companies like Intel, they are large corporations. They have a lot of capital, so they can take 5-year, 10-year bets. And say, I don't care whether I invest, a couple of $1 million in hiring 10, 20, 30 interns across top colleges, and maybe just one of them ends up joining us. That's okay because we have billions of dollars of cash pile. With startups, it's not the case because startups don't have billions of dollars of cash pile. So they want to solve their tomorrow's problem. Tomorrow something is breaking, I need to solve it tomorrow morning, literally. That's how it happens in most of the startups, early stage companies. Silicon Valley, the trend is different because the venture capital ecosystem is very mature. So startups are well capitalized. Ultimately, all I'm trying to say, the solution to your problem is to go for companies who have big money. Because companies who have big money can take long-term bets. Companies who are seed funded, less amount of money, they cannot take very long-term bets. And so, like for example, we are seed funded, 20-member company. You can't expect us to come to IIT Bombay and choose researcher. But tomorrow, if my scalability of my software is breaking, yes, I will come and hire a BTech student or an MTech or whatever student who knows scalability and help me solve my problem tomorrow. So that's the difference of time horizon, and that's why go for companies who are well capitalized. They have the appetite to take some of the bets or go to Silicon Valley. Honestly, Indian startups are not the best when it comes to being a BTech candidate and applying for research position.
Shivaram, did you have any view on this? Okay, I do have a view. I mean, so you said what should big companies do to nurture R&D? I'm not entirely sure what you meant by that. You want them to hire you directly?
No, I meant that I understand that from knowledge point of view, obviously BTech people are not that knowledgeable. Obviously, they'll go for masters and PhD candidates. But like while going to masters and PhD, what my friends think is that it is too much time to waste doing R&D. Like if they're not going to do it right after BTech, it is too much time they have to spend on themselves while doing masters and PhD. So what I feel,
so that I did have an opinion there. So no, I don't think there is a shortcut to doing research in industry labs. I think for doing a successful career in research, the combination of breadth and depth that you will get in postgraduate programs anywhere in the world is pretty much that is what industries are supporting, and indirectly industries nurture that by sponsoring. They don't want to do the teaching. We are here for them to send them a trained research talent. So I think there is no need for that role reversal. That's what universities exist for. We are doing the training. Yes, if they, like he said, if they have a lot of bandwidth in terms of cash and all of that to do the on-the-job training, they might do that also. But conventionally, they do prefer this thing that there is a professional ecosystem already existing for training research. Then let them do that. We just support that. So we have IBM fellowships, we have Microsoft awards, we have Google fellowships. They all support the existing training ecosystem, which is the universities, to train the talent. They also know, the good research labs also know that it's better to train somebody in a broad, through a university's thing with courses, with exposure to multiple talks going on and so on, before they come to us and start working with us. They know that route is better. That's why they prefer the PhDs and everything. So I think if you want to eventually get into research, don't try to do that. Don't take the shortcut. Come through the postgraduate and it will make you a better candidate for that, I think.
Hello. My question is somewhat related to cloud services and limitations of resources. So, this question is open to anybody of you. So, as we all know that it's all about data and data all. So, the question is that basically we have limited resources in terms of environmental and climate aspect of point of view, and in terms of technology as well. So we know that there's a lot, everything, it's all about data, whether we are talking about the LLMs that are trained on maybe GPUs, and also these all things require a lot of services, cloud related services. But we have limitations of resources, so I just want to know that what will be the peak level of this cloud services and resources, because we have limited resources. So maybe, but data is growing day by day. So what will be the peak level? That just I want to know that, and how we will handle this much amount of data at what that level when we have a very few resources are left. That is my question.
Who wants to take this? Priyanka? Okay.
I'm not sure if resources are constrained, right? Resources are also growing. Moore's law says that compute is also becoming 2 times faster every 1.5 years. Not 2 times faster, like in the same amount of chip, 2 times more transistors are happening. So, I mean, your assumption, on what basis are you assuming that the resources on the hardware side are constrained?
Basically, it's not only the hardware side, but my concern is all about towards the climate and environmental aspect as well. So because we have limited things as well in terms of material science as well, because whatever the data centers are made, that requires material science materials as well. So that point of view,
Physical hardware, as in the space and I don't know what you require, concrete,
I
cement.
think it's a really mature question. I think it's a great question. One person in this here realizes that resources on the planet are limited. They very much are limited. We cannot say that they are infinite. And we can see geopolitically what is happening for people to just get resources from the earth and so on. All I would say is this is maybe a tea time and dinner time discussion. I don't know if anybody, I have a cynical answer, which is people who are trying to just get ahead, companies and even academia, because we have to publish and so on. Nobody's thinking about it. Nobody's thinking about the earth. Really.
Okay, that's really wondering.
Yeah. So next question from here. Yeah, please. Yeah. So next question is specially for the industrial research area. So today we are all knowing about LLM only, and we are talking about LLMs only. So do we get to hear something new other than LLM from the industry for shaping the new future?
Brinda, Priyanka, you want to answer?
I already talked about it. I don't work on LLM. I work in industry, but I don't work on LLM.
Yeah, but
Yeah, I'll also say, echo that. I don't work on LLM. I work on the lower layer of stacks, but I'll come to the point that LLMs also came like out of a paper in 2020, right? That attention is all you need is what started the transformer architecture, right? So things might not stay the same 10 years down the line, or there is a curve every time any tech or any industry comes into, like any tech comes into play, right? And I think things might change in a 2 to 3 years time frame as well if a new paper gets published or a new research gets done. So won't really be LLMs that way. So it might change over the years. So look out for that.
I also don't work on LLMs. I work on building cryptographic proof systems, ZKVMs.
Please, can you say a little more about it?
So ZKVMs are essentially these proof systems where you can run codes and generate cryptographic proofs. The idea is that once you generate the proof, anybody can actually verify this proof very quickly. And if the proof is sort of correct, then you can ascertain to the fact that the computation that was done was correct. Now this is useful in many areas, but the main abstract use case is where there are multiple parties that are trying to verify computation done by a single party. Now, so you can bring the overall compute down by paying once the price, that the price is to generate the proof. You have to do 100x times the computation that is required for generating just the simple, like just computing the output. So this is actually a very nice problem, and this is like an ongoing research area as well, and you have interesting use cases that come out of this in the Web3 space. So it's not at all connected to LLM.
So,
Naga sir, please. Can we have some light on from your side?
Yeah.
Who are you asking?
Nagarjun, sir.
Yeah, so I want to add, so I work on LLMs, but then there is another viewpoint. So LLMs are a solution or a technology, right? But people in my lab, for example, they work on problems, not on the technology per se. So for example, there are people in our lab who is working to solve education for teachers, education for students. And there are people who are working with eye hospitals to solve, just to compensate for the dearth in eye specialists, right? So would you say these people are working on societal problems, or would you say that they're working on LLMs just because they use LLMs because it makes sense, right? Because the technology is powerful, so they will want to use the technology because their goal is to solve the problem using any and all means. And if LLMs are there to help them get there faster, then it makes sense for them to do this. So it's a perspective, I think. I mean, LLMs. I think of LLMs as a technology, as a device, as a means. But the problem I want to solve can be something very different.
So I wanted to just, Shivram, because people also equate as if working in AI is the same as working in LLM. Maybe Shivram, you can dispel that myth.
Yeah, so I think LLMs are so popular because they're facing you, right? You can go to ChatGPT and ask a question, right? But there is so much also happening behind the scenes, right? I mean, you have recommender systems recommending you products. You buy the product, it comes to your doorstep because somebody's planned the logistics. There is a lot of AI, ML in decision making, right, that is happening behind the scenes. There's work in robotics, right, nowadays, which is, I don't know, coming up with better robotic solutions for different things. So LLMs, I think, are so much popular because public easily sees it. But AI is also making inroads in, as Nagaraj also said, other areas, right? I'm working with somebody in chemistry, right, who's trying to optimize chemical reactions, right, using AI. It's happening in material science. It's happening in different sciences. You know, right, that the Nobel Prize winners in physics and chemistry last year were computer scientists, right? So, yeah, there is much more to it than just LLMs.
Yeah, thank you.
So we have a question from a faculty member.
Yeah, just a quick remark. So there was this question about research and can BTech students get into research quickly? So there's one thing that I have always noticed, there are two goals of research and often only the first goal gets emphasized and second goal doesn't get discussed. So the first goal of research is of course to do something useful and develop something useful. But the second goal of research is to help researcher become much better intellectual individual so that he can solve the problem. This is the goal that is served in the academia. So first goal is served very well in the industry and second goal is served very well in the academia. So if you want to be in research, as everyone is saying, perhaps don't try to rush. Develop yourself very well in academia and then of course you have entire lifetime to solve the problems.
Thanks. Okay, there's a question there.
So geopolitically, how can India catch up with China? Like China has their IP, they develop DeepSeek, but India has like mostly been a back office for most of the US. And our startups also mostly copy US, but despite like IIT Bombay is like leading in the most YC startups in our country. So like Y2K led to the IT boom in India, but that led to IIT coaching and then computer science craze. And now market is like saturated with the computer science jobs. And but in US, as Kunal Shah said, 80% software engineering jobs are down. So like China builds, but India is on a risk of like its FDI IT engine. So where is the workforce, because it was a job creation for most of the workforce in India. So where are the next set of jobs coming, given the entropy is on the side of job cuts, but the serendipity is if we build some IP. And so yeah, apart from Sarvam AI and other things, I've not seen other AI ecosystem in India. So where is the next IP coming that will be, that we can actually share to the world, and that will be in another IT boom in India? So that is my question.
Aman, Vineet.
Okay, so I did not completely get your question. So first part was India versus China, then about jobs.
No, IP, I think he's asking the question of how, are we going to, so Y2K was like not IP but some opportunity. Yeah, what's the next opportunity for India?
So I feel product building in India, like Aman said, the VC market is not very mature here. You see any geography that has actually boomed in from 1952 till now, even China including, there has been a lot of capital infusion. without capital infusion, you cannot expect to do some product building. Otherwise, you will end up doing service. So to build really good products, there are two things. One is capital infusion that is required into Indian markets. Second, Indians need to really think about what products they can build and they can distribute. So distribution is really key if you want, because building products today with the kind of tech that is coming out, it's not so hard. If you really sit and think, like, you have LLMs, you can actually come up with interesting use cases that you can build. But what is really hard is to think about the distribution. How can you actually get your product into the hands of the people? And you really need a lot of capital to actually build foundational infrastructure level projects. And IP comes out of infrastructure level projects, and for that you need simply a lot of capital, because every company that exists today big is coming from outside in India. There is no Indian company. Sarvam also raised pretty good amount actually for them to build infrastructure. So people who are building foundational models, they have capital. So without capital, it's very hard to actually do infrastructure level work. That's the simple answer.
I'll add a small point. See, if you look at the overall landscape, one is the bottom layer, which is the hardware layer, which NVIDIA is specializing in, building chips, Intel and NVIDIA, those kind of companies. On top of that is the layer of foundational model, which is, DeepSeek, ChatGPT, right? Those kind of models built by companies like OpenAI, right? And Anthropic, right? All those companies. On top of that is the application layer, where I feel is the opportunity for India. For example, we are not building foundational models from scratch. We are saying someone has done that job, right? Now the banks, they don't have the, capability to attract the top tier talent from IIT Bombay or IIT Kanpur or whichever, top engineering talent. So what do? But they have a lot of problems to be solved, right? A typical large size bank in India has 30,000, 40,000 telecallers. ICICI Bank, if I'm not wrong, public data, they have 30,000 telecallers. Now, hiring so many telecallers, right? 40%, almost 30 to 40% of these telecallers leave their jobs every single year because they are not very well paid. Somebody pays them 1,000 rupees per month extra, they switch their jobs. So for these banks, it's a big problem to continue hiring these talent, retaining that talent and keep up with the growth rate of the bank, right? The credit in India is growing and so on and so forth. So somewhere they cannot use the foundational LLMs to solve their banking technology needs, which means entrepreneurs like me come to place and say, look, I don't know how to train my language model from scratch, but somebody in the US has done that. I don't know how to build chips, silicon chips, whatever, GPUs from scratch. Somebody has done it. I will borrow them. I will rent them. I will buy them, whatever. You tell me your problem statement and I will apply this language model which someone has built to solve your problem. So that's where I think a large opportunity for Indian entrepreneurs lie. Of course, if you enjoy research, if you like, getting deep into things of technology, go ahead, join one of the companies building foundational LLMs or building the next quantum computing chip, which can be much faster or something like that. But if you don't want, like for example, in my third year, I did a 3-month internship at a Silicon Valley-based startup. It's a company called Rubrik, which got listed in stock market. Some of you might have heard of them. But then I took a decision that I don't want to be in the US. I kind of not like the fact that I'm staying away from my family and parents. In the final year, I took a decision that I will start something of my own. And my company has never been into deep research because, we don't have that capability. Can we build that capability? Yes, get some capital and all those things. It's a different direction. But I decided simple that someone has built the tech, someone has a problem statement who doesn't know how to use this tech to solve their problem, I will bridge the gap. That was the opportunity for me, and I think that's a huge opportunity lying for a lot of Indian entrepreneurs. Go to any large corporate. I'll give you a very good example, by the way. Last week, I met executive director of a very large bank, top 5 bank of India. In the meeting room, there was the executive director, there was their deputy CTO, there was their head of generative AI and head of HR, 4 seasoned leaders of the bank, and 2 of them from the tech side. They had invited me to take a talk, something similar, right? How can technology be used in banking, financial services, blah, 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 all those things, for the 4 of them. I started the question, they wanted me to help them evangelize generative AI within the bank, right? Among the top 1,000 people of the bank. So I asked one simple question to them. In the last 7 days, which one of you has used ChatGPT and how many times? There was dead silence in the room. Executive director has not used ChatGPT, I understand. Head of HR has not used, I understand. But deputy CTO, head of generative AI, has not used ChatGPT even once. And by the way, One of them is an IIT Bombay alum, 1990s batch. With all, I don't want to tell which of them. It becomes identifiable, but one of them is an IIT Bombay alum. Surprising that they are not using ChatGPT in today's era, even once in the last 7 days. That's where the country is lying, and they have a ton of problems in the bank to be solved. They have zero idea how to solve it. That's where people like me come in, and we are building a company, we are employing people, more and more people are coming in, so not building foundational models at this stage. So that's to give you a sense of where is the opportunity I feel for India, application layer.
Thanks. Okay, we have almost exceeded our time a little bit. So I'm going to give the panelists a chance to say, not all, but anybody has something like they just really wanted to say, then just say it quickly, 30 seconds. There is tea and snacks and students eagerly waiting to present their posters. Okay. So
I'll just go very quickly. So I'll just stick to the broad theme. So I think what we need to really focus on is, so I always think about when I joined my PhD and later part, I think about like what you want to do in 4 parts. What is the impact that you create? How much, so this from Ikigai, if people know Ikigai. What is the impact that you can create? What you like, whether you're good at it, and this is basically combined together. The second two, you have to find your sweet spot. It's called the metaverse zone. And the fourth thing is, what is the monetary compensation? Along with monetary compensation, you get materialistic, everything materialistic. And you have to find, it's like a weighted optimization. So you have weights for this. It's a very personal preference weight, and you have to optimize this. And I think if you choose and you optimize it properly, it's more self-satisfying.
thanks, Vinay. Anybody else wants to say some last question?
Yeah, I think I want to say the same thing. I was actually a little bit concerned that this is a panel on workforce of tomorrow. I mean, so many students sitting here. We've not really faced the fact that this choice is a very personal one, right? We are all very different people. So one of the very important aspects you have to consider while deciding what to do is yourself, right? Your aptitude, your strengths, weaknesses, right? The kind of things that you're comfortable doing, you aspire to do, your constraints in life. For example, a PhD, right? It can't be just another decision, okay, let me do a PhD. You need to commit time to it, right? 5, 6, 7 years, you have to cope with, failures. It's not really only your technical ability. It is a lot more about your, personality types, things like this, right? So I kind of assumed when we came to this panel that it would be more about this. It's mostly been around, technology and modern trends and so on, which is all very well. But finally, I think each of you making this choice, think a lot about yourself. You'll have to look a lot inward, right, before making this external choice.
Thanks, Shivram. Okay, so we can wrap up, or we have some thing for the panelists. Okay, one second. I just want to give one announcement before we do anything here. So there will now almost is fully posters. They will tell the schedule properly. I just wanted to tell the external participants that during the poster presentations also, we will be taking random attendance. There was a slight incident of people just roaming around. This is a slight foray into an unpleasant announcement I am going to make. This is a fully funded trip by the Government of India, basically, for you to come and participate in this. So if you're not here, basically 100% of the time, we will not be able to reimburse your travel. So please tell your friends, if they're not here, we may not be able to reimburse them. And during the posters and all of that also, it's an open time, but we will figure out how to take the attendance. So please be there till at least 6 o'clock. I don't think anybody should go, because a good 2 hours, our students are going to be hanging around. It's for you guys to, there are a lot of posters. It will take you 2 hours to go through everything. So please be there and make full use of this opportunity that has been given to you. Okay, thank you. That my announcement is over. Back to the MCs. And yeah, thank you from my end to everybody, Shivram, Nagarajan, Priyanka, Vrinda, Vineet, Aman. Thank you to the audience for really good questions, really, really good questions.
Professor Uday, can I request you to please give the tokens of appreciation? First to Professor Shivram. Then to Professor Nagarajan. Next to Dr. Priyanka. Next. Rohit sir. Now, can I call Professor Rohit for the rest? Or, yeah. What? Get what? Yeah, can you please give it to Professor Dr. Vineet? And lastly to Mr. Raman.
Thank you.
Thank you.
So we have a photo session right now. So all the participants and volunteers and even the panelists, I request all of you to assemble on the outside of the, near the stairs, just outside the Crescent building. And after that, you will have tea at the same place in the CC and followed by the poster presentations. And also every poster will have a QR code pasted to the side, so you will have the privilege to vote again for the posters as well. Whichever, like all the posters you can rate from 1 to 5 according to how you like it. And one more announcement to the participants. So as you, many of you will be needing the travel reimbursement. So in that case, if any of you have forgotten to take printout or anything, I request you all to take it today itself from, there are printers available in some of the hostels, Hostel 10 nearby and SOM building as well. So make sure that by tomorrow you get the hard copies.
Yeah, the poster rating is also for a competition. Please do rate it. The people will get best poster prizes and things like that, just based on your opinion. I don't think we have a jury. So, so you are the jury. Yeah.